Hello and welcome to another Into the Terminal. Today we're going to be talking about Podman.
I like Podman. One of my favorite
Oh,
features of RHEL. I don't know why, but it is. I just love it.
Everyone loves Podman. But I know we've covered containers in the past. And if you're interested in what we go into, like create containers and other stuff, there's plenty of other episodes for you to take a look at. But we wanted to start today with just like Podman basics. So like you're new to containers. What do you do with Podman, right? So we're going to cover things like getting a container, running a container, different options for running a container, taking a look at what it's behaving like on the system. So those types of things. Nate, do you want to get us started by jumping into the terminal?
Sure thing. We are literally starting with a basic RHEL system today. I don't even have Podman installed yet. So the first thing we're going to cover is how the heck do you install Podman? And it's actually really simple. There was on RHEL 9 and older a meta package called Container Tools, which would install Podman and a bunch of other things. You don't necessarily need all the other things. So that doesn't exist in RHEL 10 anymore. I happen to be on a RHEL 9 system, but I'm going to give you exactly what you would do on 10 as well. And that's just DNF install. We're going to add the -y just so we don't have to tell it yes. And Podman. And a Podman, there's two cool things about Podman. I mean, there's a bunch of extra features in Podman that don't exist on the Docker side. But if you're coming from a Docker background, the command line interface for Podman is practically identical to Docker, which is, I think, really cool. And the other thing is we can run things without root permissions, which is Docker runs as root because it uses a daemon. So we're going to do at least all my demos today as a standard user. So here we are. We've got a brand new system installed with Podman, right? There's the Podman CLI. We're going to just run something and kind of give you a little bit of a walkthrough of what a container kind of is and what it looks like to just kind of interact with one. So let me get my command line here. So we're going to run a Podman command where we're going to pull in a container and run it, a container image and run it. We're going to talk more about all these things in the deeper dive. We're going to run it interactively. That's what the -it flag here is doing. And the reason I'm running this particular one is because it'll just get us a shell within the container, right? And I want to kind of show you what it feels like to just kind of operate inside of a container. So here we are. It pulled the container, or it pulled the image from Red Hat's public registry, and it ran it. And now it looks like we're root inside of a Linux system, right? Now, remember, we ran this as a standard user. I was that RHEL user. And you could see from the prompt there, right? $, that was a standard user. And now we have a root prompt within our container. Now, you might say, well, that feels like you're in a virtual machine. We're not. And again, we'll talk about that in a little bit too. So here's how things are really similar, right? So I have a Linux file system. You can see I've got like an Etsy directory. I've got a password file, kind of, the stuff that you'd expect to find inside of a Linux system. What I don't have in this particular one is an init system. Systemd is just like not even running, right? The tooling is there, but it's not running at all. And that's because the container that I chose to run doesn't have an init system, because a lot of containers, when you run them, do not run an init system. You literally tell the container image what it's supposed to run. And, again, we'll talk a little bit more about that in a minute, but I'm going to give you a little bit more of a realistic demo here. That was just to kind of show you it's a container, right? It's a Linux system, but it's not really a Linux system. It's more like a walled off garden that has its own file system and its own feel like a Linux system, but it's not a full system, right? All right. So what we're going to do now is we're going to actually pull in something that does something other than just get us to a shell, and we're going to run that. So let me grab that one here. All right. Now we'll talk a little bit more about what registries are and whatnot, but what we're doing here is we're using Podman to run an image that's on the Docker Hub public registry. And the reason we can do that is because Podman and Docker are both OCI compatible or compliant container runtimes. OCI is it's a standard that basically says what a container should look like and how it should operate, right? And because Docker and Podman both respect the same standards, they can both run the same container images. So here we are. We're going to run an Nginx container. If you're not familiar with Nginx, it's a web server that can also be used as a proxy server. We usually use HTTPD, so I'm mixing it up this time. All right, so it's running, but we're just back to a prompt. Well, what does all this mean? Well, again, you're going to have to stick around to the deeper dive to find out kind of where that went and how we interact with it. But what I will show you, notice, and again, we'll dive into this command in a minute. I told it to map port 8080 to port 80 within my container. So now if I use curl on localhost, and you can map this to specific IPs or public IPs if you want to, because that's, what's the point if it's only local. On port 8080, there we go. This is the Nginx starter page from the container that we pulled and ran. So now we have Nginx up and running within a container. And we're going to go a little deeper, not too deep, this is basics, remember, on everything we just touched on and what these images are and all of that in our deeper dive. I already sort of made this parallel between a container and a virtual machine, right? They're not the same thing. There are certain circumstances where you may be running a container in a virtual machine, but we're not going to get into that because that gets into deeper stuff than we're talking about here. At its base, a container, so I guess here, let's talk about a virtual machine first. Excuse me. A virtual machine is an actual machine with a virtual processor and virtual memory isolation and all of that running inside of memory. And it runs its own init system and it runs the entire system virtualized, right? It has very little dependence on the host operating system. Obviously, the host operating system has to be able to run a virtual machine in order to be able to run a virtual machine, but it kind of ends there. It's a completely isolated thing. It is a virtual machine, right? It is all running in memory. It's got all the overhead of a full machine, right? And if you run several virtual machines on a machine, on a hypervisor, all of them have their own isolation, their own memory footprint and whatever, and they're just heavier, right? With a container, instead, what it does is it shares the environment, maybe not the environment, it shares the kernel and memory and CPU slices and all of that from the host operating system, and just containerizes or isolates those things using things like SELinux and C groups and whatnot, so that when you're running a container, things like the kernel from the host operating system are still leveraged to operate or run the things within that container, right? It's not a whole separate kernel. So what you can't do is say, my host operating system is on kernel version XYZ, and my guest or my container is on some other kernel, right? Because that just isn't the way it works here. You'd need a virtual machine for something like that. Or if you're on a whole different operating system within your guest, that would have to be a virtual machine. But in the case where you're just trying to take services and run them on a Linux host and isolate them from each other, container is so much more lightweight, and it's a lot easier way to get that done.
Yeah, and just to like double down on a little bit. So let me show you an example of what Nate's talking about here. So here's my RHEL host. This is a RHEL 9 host. And I'm just going to run a container that I built before the episode, right? So if I look at my Podman images. Oh.
You broke something.
I did.
What'd you do?
I hope I didn't break it.
Maybe you...
Okay, it's running.
There you go.
That's fine.
Okay.
So maybe I just didn't save it into my local registry. All right, so we have this Podman container running. And what's in it is a containerized Apache. And if I look at process status, and I look at just the Apache processes, what you'll see is there's this one here that's owned by the RHEL user, which is the same user I ran my container as. And then there's these other processes that are owned by this weird process ID number. That's actually the Apache daemon user inside of my containerized environment. And why that's important is that because it's running within my container, normally things like the RHEL user process there would be owned by root because it's attached to port 80 on the host. And you have to be root in order to attach to privileged ports. But did I forget to show the thing?
Shh, it's fine. We're good.
Okay.
Nothing's wrong, Scott.
Okay, I'm moving on. But because we're running rootlessly, the regular unprivileged user, RHEL, owns the container and is operating as the root user. And then inside of my containerized environment, the users are actually mapped to other random user IDs so that no one on the host operating system is given root authority on the host operating system. All right, but if this was a virtual machine, and I was running a VM and I did a PSAUX and looked for my VM, I would see one entry for the virtual machine. And I would have no visibility into what was happening inside of that virtual machine from the host operating system, right? I would just see that the virtual machine process is running and how much memory was dedicated to it and how much CPU consumption it was doing. And when we do things like C groups, where we can group processes together and manage the system resources that are dedicated to them, I could have that one virtual machine managed as a single process. Whereas with containers, I can actually go down and say, oh, HTTPD processes owned by the RHEL user or user ID 231119 should be managed in this way. And that should be separate from other processes happening on the system. So that's a little bit on like the shared environment. I also wanted to mention what Nate said about kernels. So traditionally, this is actually really hard because different kernels behaved differently.
Mm-hmm.
So you may really, it'd be important that you're running a 2.4 kernel or 2.6 kernel or 5 kernel for your application or workload or whatever your additional binaries were compiled against. We at Red Hat do a tremendous amount of effort to QA our container images so that you can run RHEL 8 containers on RHEL 9 hosts or RHEL 10 containers on RHEL 9 hosts or vice versa. And that's also one of the reasons why, like when we look at our Red Hat officially supported official things, while Ubuntu containers may work, we don't officially support them because we don't do the level of testing and compatibility testing that we could say, yes, this random container that you've pulled down for Ubuntu or Alpine or whatever works with the 5 kernel that comes with RHEL 8, right? Because we don't know what's actually inside of that container image that you pulled down and started running. So generally containers are portable, but not always. And there's some like really weird times where that's been the case. So for Red Hat purposes, we do a tremendous amount of QA to make sure that RHEL or RHEL derived images like the universal base image that Nate and I were using today work on other RHEL container hosts. And if it's not working for some reason and you have a support agreement with Red Hat, you can like ask someone to help you fix it. But that's not the case with what we would term third-party supported things, right? Where you grab a random image and run it. It will likely work because containers are built to be very portable. But there is a small chance that maybe it's incompatible with whatever version of Linux you're running it on.
Right. So we've talked quite a bit about container images, and we haven't really delved into what that actually is. Like, what does it mean when we're talking about a container image? And we've got, there's a couple things to talk about there. The first of all, what's in a container image? And there's really two core things that are in there. One is this interesting layered file system. We'll talk a little bit more about what those layers mean. And the other thing is some metadata, and that metadata sort of defines what your image is supposed to do, how it runs, that kind of thing, right? For example, that port that I mapped in, if I were to grab a random container from some registry somewhere, we'll talk about registries too. What if I pulled in that Nginx container? And now Nginx can be configured to listen on any port. Standard is port 80, so it's a good assumption that it's probably going to listen on port 80. But I could be listening, the container could be listening on some other port. Well, part of the metadata for that image, you can actually query, and it'll tell you, this is the port we expose. And in that case, it would probably say 80, right? And then I could tell it, map 80 in there.
Yeah, so I was just going to show how to do that, right? You can use Podman Inspect on the container image that you've pulled into your local repository. And down here,
right there, expose ports.
I was talking about.
Right. So if I'm building a container, which is a whole other topic, but if I'm building my own container and I am publishing it on a certain port, then I don't necessarily have to define metadata that says what port it exposes. But if I don't, then people who use my container will have no idea what port to forward in. They'll have to guess, or they'll have to do some other troubleshooting to figure out where my service listens on. But if I add that in there, then they'll know, oh, it listens on port 80. I should forward my traffic to port 80, right? Also, things like what command it should run. You can see right there on Scott's screen that this particular container, when it brings up that layered file system, it should run this command, and it's going to run HTTPD, and it's going to run it in the foreground. Now, that layered file system is a whole other topic. When you build a container, it's usually based on something else, right? You can build them from scratch, but I've never done that myself. I've seen it done, but basically it's usually based on something. Like maybe we'll base it on that UBI container that I showed my example in. And then you have a set of instructions that tell the system what else to do on top of that base image, right? Maybe you install some packages. Maybe you run some machines or some executables. Maybe you run a script that does some things within the image. And every command that runs lays down a new layer on top of that file system. So the base layer is going to be UBI in this example, and then everything beneath that is going to be another layer. And the really cool thing is, if I make a change at the end of those instructions and then rebuild my container, it doesn't touch any layer until it gets to that command that I've changed, right? So in a world where I'm building an application that I'm putting out on all of my systems, that means that the delta that it has to download when it gets an updated container image is just that layer, which is actually a really nice way of doing things. If you've got a container image that's a couple hundred meg, which is usually about the size of these things, that doesn't sound like a lot of space, but when you're deploying it to 1,000 machines or something, that could really add up, right? So having that layered file system where it's only a couple K of difference is really a big difference, right?
Yeah, and in containers, people will talk about things like the size of the container. And there are two sizes you're interested in. The compressed size, which is when you're transferring it to a new machine, that's how much data is being transferred. And then once it reaches its target machine, it'll uncompress. And then the uncompressed size is how much file system space you're using on that machine that has now received the container image into its local repository. The layer count is important because as you increase the layers, because you're making consistent changes to the container, you're adding disk space to the storage of it, right? Because it's what's called a file system overlay. So what happens is you have your base container, and then if you change a component and that gets stored as a layer, essentially what happens is when you're looking at the container, you're looking at the top layer, which is those files and directories that exist that override the stuff that's in the layer below it, which may override the stuff that's in the layer below it. And so every time you make a layer, you're adding a little bit more space to your container image. And at some point, you may want to just rebuild your container because you want to squish those layers together so there's not all this differential layering. Instead, go back to base container, or maybe base container
Right.
plus one build layer. But
Right.
it's around managing the size of the container. That's why people are concerned about things like layer count or layer or container size, essentially.
Right. And that brings us to kind of the last point, which is who makes these things? Who makes these container images? And that, I mean, could be literally anybody. It's really just like any other software packaging. It could be some guy who had some crazy idea for a thing and he published it. It could be publishers like Red Hat or Canonical or whoever, right? If they have an interest in providing container images as bases for people to build from, you could see large companies that sign these things and everything so that you have some validation as to where they came from. But you could just build your own, right? If you have your own custom thing that you need to build for your own needs, then you don't even have to publish it. You can build this right on your laptop or something and then move it around to your own local registry. A registry is sort of like a software repository, right? So imagine like an RPM repository where I've built RPMs and I put them in that repository so that all of the systems that I manage can go and get those RPMs. A container registry is the exact same concept, except it's made to hold container images, right? So Podman, Docker, a bunch of others, they'll be able to query these registries and pull in container images. And then when you get deeper into this, you have things like pipelines that do automated builds and whatever. Those can also pull from these same registries and push back to them, right? So it'll pull in a container image, do some stuff to build my container, and then push it back to the registry that my systems use to pull in their containers. So this all leads into this whole DevOps lifecycle that is really like the nirvana that container operators are looking for, right? So we did a Podman Run, and run is just like the subcommand for Podman that says we're about to run a container. There's a bunch of other subcommands, start, stop, all these other things, and we're going to talk about those too. But that's sort of the command that brings up this subset of arguments that we have that follow it, right? -D tells it to run this particular container in detached mode, which basically puts it into the background. If I did it with IT, which is actually convenient that I accidentally pulled up that other one first, I have IT in this one, that says to run interactively with the existing terminal. D says, don't show me the output, throw it into the background, and then it'll run in the background. --name is just a convenient way to tell it, what do I want this container to be named on my system so that I can find it and talk to it later. If you don't give it a name, it generates one, and they're always long and hard to type and really weird spelled, and I don't recommend it. -P we kind of touched on. This is where you can tell it what port to forward into the container. And again, this tells it local port 8080 should go to container port 80. You could also, if you have a system that has several IP addresses, or if you have a specific IP address on the system that you want to bind this particular container to, you could say, 10.1.2.3:8080:80. And that'll say this IP address, this local port, that container port. And I use that on my home lab because I have one system down there that runs virtual machines, and it also runs containers because this isn't an enterprise. This is my home lab. So what I do is I have actually several alternate IP addresses allocated to that machine. And when I run containers that I want accessible, that I don't want to step on each other, I just give them their own IP address, and then I run that container on that IP address. So that way there's no port conflicts and whatever for things that are running that might be using the same ports and whatnot. Okay,
And
so
I did want to point out the port mapping.
Sure.
Stop me if we're going to talk about this in more detail. But because you're using rootless containers, meaning they're running as a regular person,
yep,
you can't have your container bind to port 80 because that's a privileged port.
Right.
That's why we're using this high numbered port that we are choosing, 8080, and then forwarding that traffic automatically. And what it's really doing is setting up a firewall rule to take care of routing that traffic from this port on the machine's IP addresses to this container and the port that it's reserved for that container.
Right. And then, of course, the last argument I have here is where to find this container in the registry. Now, your system is going to know about a certain amount of registries. Docker Hub is usually one that comes out of the box. So are things like the public Red Hat registries. There are other Red Hat registries that require authentication, which you would have to do a Podman login to get into, but we're not going to touch on that sort of more advanced use case. But if you ran your own registry, you would just basically define that, and then you'd be able to pull from it as well. Or you call it out directly. You could say, like I said, docker.io/nginx. That just tells Podman, I don't care if I know about the registry. I've already been given the address to go get it at. Here's, let me go get that particular container. Okay, that's that command, but I want to show you a couple other things within Podman that I consider are kind of the basics that you need to know in order to manage containers, right, within Podman. So let's clean off my screen here. So remember I said there's all these different subcommands for Podman. There's Podman PS, which is just like PS. I shouldn't say just like. It's the same concept as PS in Bash, which tells it what processes are running, except in this case, it's, hey, Podman, what containers are running? And you can see here, I've got this list of any running containers. And the only thing that's running at the moment is that Nginx system that I started in the critical path. So you can see right there, that's the name of the container. It even tells me what process it's running, how long it's been up, things like that. There's also a subcommand to that called PS-A, which says, show me all of them, even if they're not running. And I'll be able to show you that as an example after I show you the start and stop commands. The other thing I want to show you while this one's running is there's one called Podman Logs. And logs is what you might think it is. Show me the console output from this particular container, right? So if we do podman logs nginx, it's going to show me the output for the nginx process that's effectively running in the foreground in the container, right? Because that's how this container is written to operate. So you'll see things like the access log in this case for Nginx, because I think the container is configured to send the access log to standard out instead of writing to a log file, or maybe it sent it to both. I don't remember. But at any rate, usually for something like a service, you'll see its active output right there inside of that console or inside of the Podman logs. You can also do a Podman logs -f, which just like tail -f follows the log. So if you're watching for an error or you're watching for access or you're just trying to tell, is my container responding to things, you can use that -f and it'll follow the log for you as requests come in. And then Control-C, like you'd expect, would get you out of that. All right, the next big ones would be, how do I start and stop containers that are already defined? So you might say, well, we already started a container with run. Well, what run does is it defines a container and then runs it, right? We can now also start and stop the container with podman stop. Right? And now if I do a podman ps, it won't show it to me because it's only showing me running containers in podman ps. If I do a ps-a, then it says show me all the containers like I mentioned before. And now you can see that it's still there. That means it's still defined. I could start it back up again, but it tells me it's exited 11 seconds ago. Right? And it even gives you the return code. So if this thing died for some reason, that return code would be something other than 0, likely. And that tells me something went wrong with this container and it died unexpectedly. And then it'll usually say, instead of exited, says like this thing cleanly shut down. I forget what it says. It'll give you a different status there instead of 0, and it'll say something other than exited. Now I can start it back up again, right? Because it's already defined. If I tried to like podman start something else, it says there's no container with that name. So if I were to define a container, it uses the name or the ID. This thing here is the container's ID. You could also use that instead of the name. Again, I don't recommend that. But if you need to be absolutely precise that the thing you're about to interact with is exactly the thing you found in the listing, that's the way to do it. You use that ID. That way it's less likely to be a fat finger typo or something.
So real quick on that, one of the things that containers are known for, Nate, is being stateless.
Mm-hmm.
Right? So you like create a new container. But in this case, when you started a container that had been stopped, what about its state?
So the state of a container will persist as long as it's stuff the container wrote to its local disk, right? Stuff that's in memory, of course, as you'd expect. When it stops, it goes away. But stuff that it wrote to the container, like the disk within the container, the whatever, the layered file system, that will persist as long as the container isn't removed, right? So if I stop and start this container, then anything that was in that image will come back with the container, anything that I wrote to the image. So if I had dynamic data that gets written to the file system, in this particular case, it'll persist until I delete the container. But that's an important point, because usually what happens when you want to update this container, say there's a newer version of Nginx or the container had a security fix applied to it, the image back in the registry, what you would do is pull down a new version of that image, delete this container, and start a new one with the new updated image. So that means anything you wrote to that container is actually lost, right? And that can be a problem if you didn't expect it to happen, right? And we'll talk a little bit about how to get around that in a minute. All right, let's see. There's a couple other commands like this. This one was, I didn't know this existed. Search. There's a Podman search command. I learned about this while I was prepping for the episode. I usually just go to the registry that I care about and search there for a container image. But if I did a Podman search for, I don't know, what do you want me to search for? We could search for HTTPD, right? If I search for that, what this does is it goes out to the registries that are defined within Podman, and it finds all the containers that match that search command, or all the container images. Like I said, I didn't know this existed. So if I wanted to go get registry.redhat.io, UBI 9, HTTPD 24, which I think that one would require a login to get. But there it is. I could go get it if I don't know what container I'm looking for. This would probably be a lot more useful if you're talking to a local registry that maybe only has a handful of images in it, or a handful of images. There's not as many name conflicts as there are with HTTPD, right?
And one other thing, so Podman comes predefined with some registries inside of it. Red Hat's registry and Docker being the two main ones. And so if you just use a short name, like maybe just do Podman pull HTTPD, it's going to ask you which registry to pull it from. Or I guess for you, it'd be HTTPD-24. Which registry to pull from, and you can actually like select it off the list.
JScar in chat has asked me to search for CTFD because I'm pretty sure that'll have less. Oh, there's still quite a few. But actually, this is a good example. What if I'm going to do Podman pull CTFD, right? Now, what it should do is, it doesn't know what registry I want to get it from. And it's just making assumptions, right? I bet there is not a registry.access.redhat.com CTFD container, right? It's just saying, do you want to try that one, right? So exactly, if I wanted to pull CTFD, I would have to know which registry is defined that has it, or I would have to specify it with Podman. With Docker, it just goes to Docker Hub. So if you're doing a Docker pull, then it'll probably just go get it on docker.io, right?
Yeah, and there's a config file where you can like define what registries are in there and what order they're checked. So if you want to default to Docker first, you could do that. So that's like beyond the scope of our episode today, though.
Right. So two more I wanted to cover before we move along, and that is Podman image list. This tells me what container images Podman has pulled and stored locally. Podman actually maintains a local registry, and every time you pull an image, it goes into your local registry. You call it directly, it'll assume, right? If I do a Podman run on Nginx, it'll assume local, right? But if I wanted to say, for certain, I want it to run my local Nginx one, I would say localhost/Nginx, right? And it'll run the local one. If I've built a local container image, then I would say localhost/container image name. And then it would make sure it would get the localhost version of that image instead of trying to go out to my registries. So just keep that in mind. It's always best practice, if it's a container image that you've built locally or that you want to run the local version of it, precede that with localhost/ and then the image name. So along with image list, you can do things like, I don't need the UBI container image anymore. So if I do a Podman image RM, then I give it this image ID. I could probably do the registry.access.redhat.com / yada, 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 yada. But it's easier with the container image ID. Now it'll remove that particular one from my registry, my local registry. If I had a container defined that used that image, it would stop and not allow me to do that. So keep that in mind. If you get an error that says a container exists, then you have to delete that container first. Now, if I do an image list again, all we have left is Nginx. And I guess I did miss one. We skipped over it because we got kind of off track. Once you've stopped a container that you don't want to run anymore, right? Let's say we're done with Nginx. We don't care about it anymore. Podman RM Nginx will remove that container, right? So that container definition goes away. And now if I wanted to, I could delete the image. There's another command, like a subcommand for image called prune, which is a cleaner way to say like old container images that I haven't used in a while, or maybe older tags of a container image that aren't in any defined containers anymore. That'll clean up all those old images. So if you did a Podman, if I spell Podman right, if I did a Podman image prune, it even gives me a warning. Are you sure you want to do this? It removes all dangling images. And if you tell it yes, then it would clean stuff up. I don't think it'll get that Nginx one yet because we just used it. I think there's a timeout, essentially, like if you used it recently, it won't remove it. Or if it's the latest version of the container, I don't remember what the exact criteria it has to meet for prune.
So Nate, I wanted to return to one option from the critical path.
Sure.
Your first container that you ran in the critical path was the UBI one.
Mm-hmm.
In that invocation, you used an option called -rm.
Yes. Yeah, so --rm will tell it, once this container stops, delete it. right? And that's great for testing purposes, or in that case, it was a container I knew I was never going to run again. I was only bringing up a shell to show you guys around what was inside of it. What that does is as soon as I exited that container shell, the container shut down and Podman deleted it. If I ran it in the background, then it would be safe until I stopped the container. As soon as I stopped it, it would delete it. So it's really good for, I just need to run a thing to test something and I don't want to have to worry about deleting it later. You probably don't want to do it on the containers you really care about, because then you'd have to redefine them every time. Unless that's what you want to do. Maybe every time you start that container, you want it to get the freshest copy you can. If you add that RM, it'll delete the existing container every time you stop it.
Thanks.
It's a new it's a whole different mindset than you treat with like a virtual machine or a system you've lovingly handcrafted, right? You have to be comfortable with these things being blown away at a moment's notice. So our next demo, then, we talked about that persistent data and how it goes away, right? How anything that wrote to that container will be deleted if you delete and restart that container. How do you get around that? Well, you get around that by passing in what's called a volume within Podman. Now, there's a whole bunch of more advanced ways to make volumes than what I'm going to show you right now. Like you could point a volume at an NFS share, right? Or you could... Well, there's a few ways you can do volumes. What I'm going to do is pretty much the simplest way I know how to do a volume. And that is when we invoke the container, there's a command line argument that says simply map this directory to that thing within the container. And that's the -v flag. So first we need to do a little bit to set some stuff up here. Let's see. Yeah, let's do a make dir for, I don't know, just call it app. And then inside of the app directory, we're going to make an index HTML file. And I don't know, we're just going to do like, oop. Wow, I can't type. And I'm sure that really matters whether I typed businessy correctly or not. Manager Scott will come and dock my pay. Okay, now it's just super businessy. And that's just an index HTML file. Now we're going to stand up a container that maps that particular directory to a directory inside of our container. Okay, so we're going to do Podman Run again. We're going to do that -d like we talked about. And then I have this new flag here, -v. And what -v is doing is it says inside of the working directory, there's a subdirectory called app. We want to pass that through to user share Nginx HTML. And that just happens to be where this container stores its web root, because it's an Nginx container and because that's where the container was configured to store its web root. The :z is important, at least the first time you run it, because what that does is it forces the system to fix the SELinux contexts on the file system in the host, so that the container is allowed to read that particular subdirectory. Now, you could do that manually, right? It's like Containerfile T, I think, is the context you need to set it to. But it's a whole lot easier to just let Podman do it for you, right? And I can show you what that looks like after we run this. And then the -p we talked about before passes in that port. We're going to give it a name, my Nginx2, because I didn't want to worry about trampling other containers. And docker.io Nginx, right? So we're going to run this. And then if we do a Podman PS, there it is running. Now, if I do an ls, z, and then d, I guess, for app, it'll show us that it fixed the SELinux context to Containerfile T, which is exactly what I was talking about. So you, like I said, you could do that manually with SELinux if you wanted to, but I just think this is easier. Why would I not do it this way?
Well, I noticed also you'll see a couple different SELinux fields that maybe you have not seen before, specifically the sensitivity and category.
I've never worked with those fields.
Yeah, so, there are a bunch of places where those fields can be used, but what we're using them for here is to make sure that other containers don't get access to this container's mapped content.
There you go.
So even though you have, it basically is like tightening the sandboxing to make sure that this thing is only available to that container that's running and accessing it. But Nate, I think this ties into something that you said earlier in the episode, which was how to handle dynamic data.
Mm-hmm.
Cross container images or container runtimes.
Yep.
Is this how you would do that?
Yeah. So if I were to delete the Nginx container and make a new one, then this particular volume would persist. Same concept, right? If I mentioned before, you can map those volumes to something external like an NFS share. If I had 2 or 3 Podman hosts that all need the same application data, and they're not going to trample each other, right? Your application has to be written to be aware that other instances are using the same data. They could all map to the same NFS share and get the same data and run the same application, which is really handy if you're trying to run things at scale, especially if you're using like something like an OpenShift or a Kubernetes, which is, again, more advanced than we're going to talk about today. But if you have more than one system that needs to access the same data, this is a good way to get that done, or more than one container, I should say. All right, so now that we have it running, let's see that it worked. It should say it's super businessy, right? There we go, super businessy. Now, if I were to make a change to that index.html file, right? Now we've got some more business to put on our website. Now, if I'm not restarting the container or anything here, if I now use curl to check the website again, it should have my changes. So there we go. So you can see how this would be a lot more convenient. The other way to do this is to make your own container image and copy your website data into the image, which has some advantages, right? It makes it more portable, easier to stand up a new instance of your website. But if the data were to change for some reason, you'd have to redeploy all those containers. So there are cases where this makes more sense, especially where this is not a website, but it's like a database, right? Something that you would not bake into a container that is supposed to be dynamic and very application specific, right?
Yeah, and I was just going to mention that, like, if your database of data can be very large, and so if you were to stick that into your container, it would be a very large container. So now you can kind of separate your data layer from what you're storing and accessing from the application layer, which is like the version of Postgres you might be using, right? So you could upgrade the version of Postgres you're using, but still have access to the same database contents on that Postgres database underneath.
Right.
So Red Hat has put a ton of effort into a graphical application called Podman Desktop to help provide a developer experience for working with containers. So why don't we toggle on the Podman Desktop screen? And this is just what it looks like. I've got it installed on my Mac. So the Podman Desktop team actually has done a lot to try and support alternative operating systems, specifically Mac and Windows. So if you are wanting to do Podman-y stuff or containery stuff, Podman Desktop has a client for your Mac or Windows machine. And so you can see it here. This is kind of the dashboard where you log in. What's really cool is you have this 1-hour self-paced class for like getting started with Podman, which you could take, but also it reports on the system services running that support this. So I have the Podman machine running behind the scenes, Red Hat Developer Sandbox, and then newer to us is boot CVMs, which are image mode based virtual machines. So that is also included, but I've not installed that on my Mac yet. Podman Desktop uses the native hypervisor for your operating system. So for mine, because it's a Mac, it's using the Apple hypervisor behind the scenes running things. For Windows, it ends up using Hyper-V behind the scenes, or for your Linux box running Podman Desktop, it'll use KVM as the default hypervisor for running any backend machines. So just navigating over here on the left-hand side so we can look at our containers. We'll come back to this in a second. Pods. So we've done another episode on pods, which is running multiple containers together that share architecture and networking and a whole bunch of things. So I'll leave you to that episode if you're interested in Nate's excellent walkthrough of working with pods. But what I'm going to start with is images. So these are the container images that you have downloaded and can run on your machine. And the default is that Quay.io hello Podman image, but I've also pulled down a couple of others. I pulled down the Ubuntu image from Docker Hub. I've also pulled down UBI version 9, our universal base image for RHEL 9. And if you wanted a different image, you just kind of hit pull here and you type in what you want and you can pick it off the list, right? And you can click pull image and then it goes and does the needful and pulls it down. So once this is finished, it'll have a button that says done. And now I have it in my list. And if I'm interested in running a container of this type, I just hit the play button over here. And you can set up things like any additional disk volumes that need to be mapped to it, or networking settings like ports and that type of stuff. Or if you don't care about any of that, you can just start container. And here it is, Epic Brown, right? And I can do things like list and interact with it. So over on my containers tab, right, these are all the containers that I've got on my machine. And so this UBI 9 one that I started before the show is running, as well as Epic Brown here. And then this one I killed off that I was experimenting with a few days ago. And so you can just click on it and access it. TTY is its terminal, right? So you can do things like DNF install, I don't know, tmux. And it will go through and use the, tmux isn't included in UBI 9. How about, well, I'll let it go. So you can see that it uses UBI repos and will pull in software that is included with the universal base image if it's not already installed on the container. For this one, I did install Apache a while back. And actually, let me go back to my list of containers. I'll start up Epic Brown here. Right, so I can install Apache as an example, and there you go. And so you can use this to kind of build your container image, and then once you've got it set the way you want, you can use this download button, and it'll pull the tar archive that is your container down, and then you can take that tar archive and put it in registries or wherever else you need it to go. So yeah, it's a little bit on using a GUI to work with containers. Podman Desktop is free and open source. You're welcome.
So the thing I like about Podman Desktop is not just that it gives you that nice little GUI for, especially for like beginners or maybe not even beginners, right? You can certainly do advanced things within the GUI, but it also gives you the command line interface on the system that you're running it on. So in my case, I use a MacBook for work. A lot of people do that. But if I want to do Podman stuff locally, you're not tied to just that GUI. You can also do the command line right inside of the shell on your MacBook, which I think is really nice, right? There's a lot of times where I need to test out a container, or there's a couple things we do for work that have a container that will support like a testing environment and not having to have a VM to run it, or at least not directly, right? Because it's still doing it in VM. It's pretty handy. But I've also got a quick demo that we'll get into sort of the command line side of Podman. And we'll touch on that quick, and then we'll get into the deeper dive. So you get a twofer in today's critical path.
The graphical way run by Scott, and of course,
right,
way done by,
because that's
not as Nate. I see how you set this up.
Yep, that's totally what we did. So a lot of the times when you get like that intro to containers run through, somebody will give you this real completely useless but functional, oh, run this container, you'll see it come up, here's how you map in a port, and then they're done, they move on to the next thing. That's great for things that are completely self-contained, but that leaves out so much. So the demo I cooked up for this morning or this afternoon, wherever you are, is we're going to run a database in a container, but we're actually going to give it persistent data, and we're going to bring in a database so that you can actually see how that actually works, right? So we're going to run MariaDB. Let me get well, first of all, let me show you. In my home directory here, I have a database subdirectory. And you'll notice that it is currently empty. There's nothing in there. What I'm going to do is I'm going to run this container, and I'm going to map that database subdirectory in as a volume for Podman to map to the data directory for MariaDB. Now, if you're not familiar with MariaDB, this is a source, I guess a fork. Yes, that's the word I'm looking for. A fork of MySQL. So if you're familiar with MySQL, you'll be familiar with MariaDB. That happened, my God, a decade ago now. So I guess if you're not familiar, I don't know where you've been. All right. So, I accidentally got the second line of this I didn't want to do. There we go. Okay. So what we're doing here, you can see we're doing Podman Run. That just tells it run a new container. And if you've ever used the Docker CLI, you're going to notice that the syntax is identical, and that's on purpose because we want these things to be interchangeable. Podman and Docker will run the same types of images. They're all OCI compliant images. And it's literally copy and paste. A lot of times when you find a Docker image, it'll have instructions about how to run it. If you just copy the Docker run command that they give you as an example and replace Docker for Podman, it'll generally run, right? So really nice and compatible at that from that perspective. Now we're going to name it MariaDB because what else would you call it, right? This is -p maps in a port. So we're going to map in port 3306 because that's where MySQL/MariaDB usually listens. You can also tie this to an IP address. So in my home lab, for example, I have a bunch of containers running, and sometimes they are on the same ports. And I don't do like an ingress controller. That's more advanced stuff that we won't talk about today. I just want them to be mapped to IP addresses. So I have virtual IP addresses assigned to my host. And then you can just say, 192.168.0.5:3306:3306 will say this IP, this port goes to that port, right? So it is extensible like that. This -v flag tells it what volume we want to map in. And we're going to say the local directory called database within the path that I'm in right now in my working directory maps into varlib MySQL, which even though this is MariaDB, that's where it stores the databases. And this :z here, that's a shorthand. What it'll do is when it maps the volume in, it'll automatically fix the SELinux contexts, because if you don't fix them or set them properly before you run this, your container won't be able to write to the directory you just mapped in. And I can count on many, many, many hands how many times that's happened to me because I forgot to change the SELinux context. So the :z is a quick way to get that done. It'll automatically set the SELinux context before it starts. All right, this -e is an environment variable that we're handing in. This particular image is configured so that it'll read the environment variable MariaDB root password and set that to the root password. There's other ways to set the root password. You don't have to pass it in an environment variable. If you're worried about, I have a password in clear text, I don't blame you. This is a quick way to get it done for this example. You could pass it in a separate file. You could have it generate a random password. There's lots of ways to get this done. And just for fun, I told it to create a database as it starts up. There's another variable called MariaDB_database. I just gave it MyDB. We're not going to use that database. I just wanted to show you that it's possible. There's a bunch of other environment variables that you can pass in for things like making a user, setting the password for the user, and lots of other things that you could get if you go to Docker Hub and look up the MariaDB database or MariaDB image, the documentation that tells you what those do. And then the last thing here is, of course, what image we want to run. And I've called out docker.io directly because otherwise Podman's not going to know what registry to pull from, and it'll ask you, right? So to save time, I said docker.io/MariaDB. And you can get that from the registry that you're getting your container images from. They'll generally have just a copy paste button, or Docker Hub is pretty simple like this. All right, so we're going to run that. And all it's going to spit back is this identifier. Now, that's an internal Podman identifier. I think that's the ID of the container if you weren't going to call it by name. If I do a Podman PS now, it's going to show me that I have MariaDB running. And there's the name of my container, right? We'll go a little deeper in the deeper dive about what else we can do to interact with this container. But I did want to show you at least that it's working. So remember that database directory that we had that was empty? Now it actually has a directory structure in there because it made the supporting databases that MariaDB requires, like the MySQL database. And there's that MyDB that I told it to create, right? So now the reason that's important is when you run a container, its state is all contained within that container, but it doesn't change the image. The image that you pulled will always replace the container when you recreate it, right? So the way you normally work with a container image is you have it pulled down, you run a container from it, and then when you stop that container or you need to update it for some reason, you delete the old container and make a new one. When you make the new one, any state that was in the old one goes away. So you need some way to store that persistent state, and that's what the volumes are for, right? So in this case, all of the things that MariaDB really cares about are stored in varlib MySQL. If I delete this container and make a new one, but map that same volume back in, it'll come up with the same state as the old one, right? And that was a thing that took me a long time to wrap my head around when I was starting to work with containers. The state, the container itself is essentially stateless. Once it goes away, all the state goes away. but the persistent data needs a place to live. So that's what these volumes are for. Now, some containers are really complicated. They have a bunch of volumes that they need. Some of them are really simple. Maybe you run a container that doesn't have any state and you don't need to map a volume. That's entirely up to how you create the container, how your application runs. All right, so I want to do one more thing here to show you that MariaDB is in fact working. We're going to connect to the database. Just copy paste so I don't have to typo stuff here. So we're going to just use the MariaDB client. We're on the Podman host here. I didn't connect to the container or anything to get this done, although there are tools to do that. Just I wanted to make this as simple as possible. So MariaDB, we're going to connect as the root user. I told it to ask me for the password, and I told it what host to connect to. If you remember from the command line earlier, the password is just Red Hat. Really secure around here. And now I've connected to MariaDB. And the other thing I wanted to do here is I have a MariaDB MySQL dump, or a MariaDB dump, I suppose, of a sample database that I found on the internet. I'm just going to paste that in here. We're going to tell it to source this SQL file that's inside of my home directory, and it's going to bring in that additional database. Now, if I did a show databases, there we go. We have this new one called Classic Models. That's the one that came in from the internet. And of course, I could go in there and I could do selects and inserts and whatever in there. But the really cool thing here is if I go back out and look at that database directory, we should now have a Classic Models. There we go, subdirectory. So you can see that as soon as the data gets written in the container, it actually passes straight to that volume. So if I were to right now kill off that MariaDB container and make a new one, I'd still have that data there. And that's the start of my demo. That's the critical path of my demo. So in the deeper dive, I'm going to show you how to make your own container image. We're going to build one from scratch using UBI. We're even going to put a custom, quote unquote, custom application in it. Folks that have watched the show for a long time will probably recognize the application. And we're going to talk a little bit about some troubleshooting stuff that you can do, because sometimes you just need to interact with a container in a more direct way than Podman from the host will give you access to. And you just need to get in there, just like Scott was showing with that TTY. I'll show you how to do that from the command line.
All right, so stay with us. So Nate, you said something before we transition to the deeper dive that said, we'll show you how to make a container from scratch using the UBI. And
yeah,
those are words that collide for me, because to me, containers from scratch mean I'm starting with a file system overlay and I'm going to put in everything in there that I need in my container. Whereas UBI is a universal base image. So there's already a prepared pile of stuff that I can work off of as a builder. And so I just wanted to clarify, we are going to be building on a base image and adding more stuff to it. Oh, I don't think we're covering scratch containers today.
No, you're right. To be quite honest, I don't think I've ever actually seen somebody do that for a good reason. Almost everyone I've ever seen build a container, they start from someone else's base, whether it's a Debian base or an Ubuntu base or a UBI base. They always start somewhere, Alpine, something like that. So yeah, when I think about building a container, quote unquote, from scratch, I never think about that level because I just never see it done. I'm sure people have valid reasons for doing it, but most people that I've seen don't.
Well, most of the reasons people give are things like size.
Yeah.
Right. Because you're copying this container around as you pull it from a registry into your machine and then you're storing it. That said, like there's a lot of nice things that base containers provide you, especially things like UBI, right? Where you saw me earlier, I did a DNF install HTTPD and it magically worked and pulled the repos and it was fine. Whereas with a scratch container, you would have to like find that software and position it within your container environment, just the executables, because you don't have a package manager in there unless you put a package manager in there. So that's usually the like design consideration is space. And what you're sacrificing for all that space is like all of the modern conveniences. It's like, I don't need water indoor plumbing. I'll do it myself.
Right.
Yeah. So we actually do have a lab on building from scratch containers.
That's a little deeper, I think, than a episode on container basics should probably go. But yeah, these images come from somewhere, right? And generally, they're maintained by whoever owns that project, right? So like UBI is maintained by Red Hat. I would suppose that the Ubuntu and the Alpine and the whatever bases are maintained by those projects, right? So you don't have to worry about I shouldn't say you don't have to worry about. You have to worry less about what's in those because you imply some trust to whoever built it, right? So in the case of UBI, you trusted Red Hat, right? The other thing is we rebuild UBI frequently enough that updates that are important are built into UBI. So you don't have to worry about, I've pulled in UBI, now I have to install updates, right? Instead, you would rebase your container every so often on the upstream UBI, right? Which is kind of the way you would handle it with really any container-based image. And containers are built in layers, right? So you've got that from line. We'll talk a little bit more about this when we go to actually build. You've got that from line that says base it on this. And then every command that you run within there is another layer, right? Now, what you could do is I could build the Apache container that I'm about to show you how to build, and then I could publish that. And then someone else could say, I'm going to take Nate's Apache container and put my application in it. Or I'm going to take Nate's Apache container and add in this other tool set that I really like to have inside of my Apache builds, right? And then they could base other images on that. It's like this crazy treed ecosystem where you can just kind of base one thing off the other because this base you really like and you don't want to have to do that from scratch. So it's good for standardization too. We did a episode a couple weeks ago on image mode and we touched on the same thing. Same concepts apply there, right? You can have this base image that your corporation has accepted as your base, and then you can have these sub images that are all based on that. It helps with compliance and whatnot. But I think we should get back into the terminal. Do we have any questions first?
There were a bunch during the critical path that I think I handled things like, oh wait, SELinux. So I threw in an SELinux episode for them to watch. Questions on OpenShift, so I directed them to the OpenShift YouTube channel so they can get access to the OpenShift experts. Whereas,
yeah, I don't know enough about OpenShift to talk anything OpenShift. So
yeah, we're the relevant.
I do containers on Podman, and that's about where it ends.
Right, Kubernetes is not our jam, but there are people at Red Hat who do a lot. So like,
absolutely.
Go over there and talk to them.
That in itself is a good point that we really didn't touch on. We have OpenShift, right? OpenShift is a great platform. So why, Scott, why are we running containers on plain old RHEL when OpenShift exists?
Well, mostly because we have like really small instances and we can literally run the containers as services and other things on those instances and machines. We also don't have a lot of orchestration needs,
right?
Which is like, I know that we mentioned pods in the critical path where it talks about like tying containers together and starting them up as a unit, but we don't have things like, oh, we need to create a file system and mount it into or make it available for the pod or container as it comes up, right? That there's all these prerequisites to the container running that Kubernetes would provide as part of its orchestration of managing it. Things like failover between different nodes in the cluster, and like there's a whole bunch of additional higher level enterprisey features that one would want for containers that Podman doesn't provide natively, but Podman is great at running containers. And in fact, it's the underlying technology for running containers in OpenShift as well. It's all the extra stuff around clusters and reliability and resource management and all that stuff that Podman doesn't natively provide. So if those are features you don't need, Podman's great. If those are features you need, then you start looking at things like Kubernetes and OpenShift to get you there.
I always compare it to, and for all I know, there's people in our audience that don't remember these days, but almost 2 decades ago, when we were talking about virtualization, when the world was moving from physical machines to virtual machines, you had 2 very different classes of virtualization. One was single host virtualization, where you'd run virtual machines on a single big box. And that was great, right? It would let you consolidate hardware and whatever. You get all those benefits of virtualization. But if that machine dies, you've got all those workloads down, right? And you've got no clustering, you've got no failover, all of your workloads are down. But then there was the other camp, which is clustered virtualization, enterprise level virtualization, where you have several machines running the same workloads. And if one of those dies, it just takes seconds for it to come up on the other one. It's not an exact analogy, but OpenShift is sort of like the clustered virtualization in that example, where Podman on RHEL is more like the single host virtualization, right? Not exactly, right? But same concept. You get the idea if you think of it in that terms. Podman is a great host for smaller workloads or for workloads that don't need that level of redundancy and whatnot. or automation. There's a bunch of automation you can do at a Kubernetes level that you could probably do with like Ansible and Podman, but not in the same way you do it with Kubernetes or OpenShift. I have created in here a directory structure for my app. Okay, my app only has what's called a container file within it. We're going to walk through that briefly. I talked earlier about how when you build a container, you base it on a base image, unless you're building it from real scratch. But in this case, we're using UBI as a base image. You define that base image with this first line in this container file called from. I'm building from this other image, from docker.io /Red Hat /UBI. Now, there's other places to get the UBI image. I'm just using this one because, well, it was convenient. And then I'm literally running a command, dnf-y install httpd, because I'm going to put, that's going to be the application that I'm running within here. And then I'm using dnf to clean itself up because I don't want that extra cruft in my container, right? So when dnf runs for the first time, it builds a bunch of cache and it stores packages. And that's all stuff that maybe if I am publishing this container, I don't want to make other people download every time they pull this container image, right? So it's good practice. Clean out your DNF cache after you've done your installs. If I was going to do several installs, I would wait till the last one to do the clean, right? So that makes sense, right? This expose line says what port is the application that's running on my container supposed to listen on. This isn't like a firewall or anything. It's more like metadata that gets written into the container image so that if I hand this container image off to someone else and they want to run it and they're like, what port should it listen on? They can check the metadata for that image and it'll tell them expose port 80 because that's where this application runs. If I reconfigured Apache so that it runs on port 8000 or something, I should then expose 8000. So when someone runs it, they know what port they should expose. And then the last thing I have here is the entry point. Now, there's two ways you can define what command the container image is supposed to run. There's CMD and there's entry point. And there's some nuance as to which one you use when. CMD is more like the default that can be overridden. And entry point is more like, if this container is running normally, always run this, right? And there's better definitions than that online. Maybe I'll find the link and we'll throw it into the show notes if you want to read more about that. I'm using entry point here. We're running HTTPD and there's a command line argument. You have to define them like an array like this for entry point. That's why the syntax looks like this. But if you were running this right at the command line, it would just be HTTPD-D foreground because that's the command line option to run Apache in the foreground. The reason we're doing that is because the output of the container will end up in the container logs. And we kind of want that to be the service that's running. We want the output of the thing we just ran to be in the container logs so that we can see that. And I'll show you that in a minute. All right, so we're not going to make any changes here. We're just going to build this container. And that's actually really simple. We do a Podman. In fact, let me copy paste so I have less chance of typoing here. Then I'll explain to you what we're doing in the command. So Podman build, right? Pretty straightforward. We're telling Podman to build the image. -T is the tag. Now, you can get a little more complicated with the tag. What this is implying is that I'm building a local image called my app, right? If I was going to push this to an external registry, which is another thing that we're not really going to touch on today, but remember when I did that from line, or we're using the docker.io address for where to get containers from, that's our public registry, right? If I were building this to publish on Docker.io, I would have a path to where my registry lives, or the registry for this container lives, and it would be docker.io /nate/httpd would be the name of my container. And that's what I would put in the tag, right? And then when you build it, it doesn't automatically push it up there. It just tags it that way so that later, when you're sure that your image is working, you do a Podman push, and it'll push that up to the registry that you had defined. But again, we're not working with remote registries here. This is going to build a local one, and I'll show you what that looks like in a minute. So you can see it's basing it on that UBI. It's running that DNF command that I told it to run. It's installing Apache. And then it'll actually call out the other things that we told it to do, like expose port 80 and set the entry point. And then it says it's done, right? So clear the screen here. If I do a Podman image list, now in my list, I have localhost /myapp, which is the one that I just built. And then, of course, those other two images that I've been working with already, the UBI image and the MariaDB image, right? So now I can actually run this container if I want to. So Let me copy paste that too. So what we're doing here is, again, Podman Run. You saw me do this earlier, so I'm not going to step through every single piece here. The -d says to do it in the background, runs as a detached container. This flag, the --rm, is just for my cleanup purposes. When I stop this container, I want it to delete it, right? That's what rm means. Maybe you don't want to do that, but it's great for testing, especially if you're like, I'm not sure if this thing's going to even work, and I don't want to have to delete the thing manually after I'm done. You put that --rm in there, and as soon as it stops, it'll delete the container that you're setting up. And of course, I gave it a name. I told it what port to pass in. Even though it exposed port 80, I still have to tell Podman map the port, because I could map a different external port to the container port. I could say map port 8000 to port 80, and then it'll listen on port 8000 on my host, even though the container is set to listen on port 80. And then I told it what image to run. Now, I could say localhost /myapp, but it implies it if it can find that image locally.
So one quick note there, Nate.
Sure.
Excuse me. The port mapping. Nate is running this this container as root. And as root, you can do things like attach stuff to low-numbered privileged ports. Like
Right.
port 80. If you are running as a unprivileged normal user, if you try to run this Podman command, you get an error message about not being able to bind to port 80, because as a regular person, you have to attach your services to ports above 1024. And that's
Right.
where like the port mapping, where it's like a high numbered port to a low numbered port, come into play, where it's high numbered on the container host and it goes to port 80 within the container, because that's where the service in the container is listening. So there are some like slight variants if you're doing user unprivileged containers or rootless containers versus containers running on your machine as root.
And that's a thing we haven't even touched on. I'm doing this stuff as root. You can absolutely run these containers, build these containers, whatever, as a non-root user, which is one of the neat things about Podman. I don't know if this is still the case. I think it is. But Docker, you always had to do things as root because it was working with a rootful daemon, right? Again, I haven't touched Docker since I started using Podman with RHEL 8. So what is that, 6 years ago now? So maybe that's changed. All right. Sorry, go ahead.
Oh, I had one more thing on that, which is our recommendation is that you do things rootless by default. We're doing it as root because then we don't have to deal with some of the more complex things like port
Right.
mapping. The other thing about rootless containers is that within the container, the processes running inside of the container believe that they are running with root authority. So like if Nate was to attach to this container right now, Apache and other stuff inside of the containerized environment would believe that it's running as root on inside of its container. The reality is, if we're to look at the process status, like a PS command on the container host, you may see those process IDs running, but they're running as a privileged user account, which is kind of what you want, right? You don't want your container, something wonky in your container, to then give root access to your container host, which is what running a root like this can provide. So rootless is definitely the way to go. We're just trying to keep things, some of the eccentricities of doing that, hidden from you.
Right. Yeah, there's definitely things like file system permissions that you need to deal with when you're running rootless. There's also SELinux sometimes gets in the way. When you're talking to other services, it's sometimes tricky. But again, for the sake of our Podman for Beginners demonstration, we didn't want to delve into like the craziness there, right? So we have our container running. If I do a Podman PS, now we have two containers. One of them is the MariaDB that we were running earlier, and the other is my new MyApp that's running, my HTTP. And we talked before about running in the foreground. If I do a Podman logs on my HTTP, it'll give me the output of the daemon, which is essentially just, I couldn't reliably determine my server's fully qualified domain name. And that's expected because it doesn't have a fully qualified domain name because it's running in a container. Doesn't really affect running of the service. But if something horrible went wrong and it couldn't run Apache, this is where you would get the output, right, from the command line that you ran. And that's sometimes really, really valuable, because otherwise, once the container has stopped, now remember I used that rm command, this is where it can burn you. If the container did not run, it would have attempted to run, it would have crashed out. It would have gone back to a non-running state and immediately deleted itself. And then I wouldn't have had any logs to look at. So if you're troubleshooting, sometimes don't use the --rm because you may not have any logs to look at if it didn't work. So you're just things to think about, right? Okay, so of course, the ultimate test, let's make sure this thing's working. Now, remember, I told it to listen on port 80. So now localhost port 80 should get me to my container, and it should just get me the Apache It Worked page, or the RHEL default page, which is exactly what it did here. I know that's a lot to look at on the screen, but just trust me. That's the It Worked page, like the welcome page that you get from either Apache or Nginx when you run them on a RHEL box and don't specify any web root or any additional content to serve as the web root. So I'm going to stop that container, because what we're going to do next is we're going to actually mimic like code that we've written that we want to add into this container. Because a container that just runs Apache, obviously what you could do, you could map a volume into var www httpd or var www html and serve from a local volume on your machine or on your Podman host through Apache, right? And that's one way to do that. You could certainly do it that way. But what a lot of people do, especially when they're making a container for an application, is they bake the application code right into the container image. And then they write it in such a way that it's happy running in a container, and it will use those external sources of data like volumes like the MariaDB database did for us, where we just mapped in varlib MySQL, and it was very happy with that, for the persistent data points, right? So what we're going to do is, let me clear the screen again so you can see, we are going to bring in Scott's favorite application. Does anyone know what Scott's favorite application is? Scott's favorite web application?
Man.
It's Clumsy Bird. So imagine you're a developer, you wrote code, you probably put it into a Git repository somewhere. Now, if you're also the container maintainer, you might just put your container file right there along with your code. And then when the thing builds, it just copies the things it needs in and off it goes. But in my case, I'm not the maintainer of Clumsy Bird. I just want to build a container that runs Clumsy Bird. So I made an HTTPD container because that's the supporting service that Clumsy Bird needs to be served. And then I've used git clone to pull in the root, of the code for Clumsy Bird. Now I have to get it into my container image. And that is done by opening that container file back up. And there's a new command I'm going to show you called copy. Okay, now you could use this to copy in a script that you need to run. You could like copy that in and then have that run when the container starts up, or you can use copy to put in a web root. You can use copy to put anything that you need to put inside of this container. You use copy to copy things in with. So we're going to copy the Clumsy MSY-bird. In fact, let me copy and paste this because Clumsy is a hard word to spell. The last thing I need is to mess that up and then not be able to build properly. So we're going to copy from the working directory that we're building from, Clumsy Bird, into var www.html. And that'll do a recursive copy. You don't have to specify any extra commands to say do it recursively or whatever. It'll just take that directory and put it in var www.html. And then everything else we're going to leave the same. Go ahead.
I actually had tried this a while back. I was like, oh, I'll just use Git and direct Git pull it into my container environment. And then I realized that then my container environment also had to carry Git.
Yes, you can do it that way. And I have done it that way in the past, but there are better ways. And that better way would be to use a continuous integration workflow so that you're not cloning every time you're going to build the container. Instead, automation is doing it for you. Again, that's a little bit deeper than a beginner's course, but stuff like GitLab or GitHub or lots of other things will let you do continuous integration, where basically it runs a job. And what the job will do is set up your build environment, clone in the code that it needs, build your container, and then spit it out into a registry when it's done. So all the things I'm showing you manually here would be done with automation, which is really as it should be. But you need to know how to do it first, right? So here we are.
Of course.
Okay, so we're going to save this out. And now all we're going to do is really, I'm going to use my history command here. to find the build command that I did before, because we're not going to change that. There's really no reason to. We updated the container file. We're going to have it build. It's going to replace the image that we built with the new image. Now, the cool thing about that layered file system that it uses for container images is it doesn't really care about the things that are already in the image, right? All it's really changing is from this line forward where I did the copy, right? Because the stuff before it, notice it didn't do the install of HTTPD. Otherwise, you would have seen the output of DNF right there. If we didn't have the Docker, the from line there, if we didn't have that image locally, it would have had to pull it down again. But since we didn't change it and it's still local, it didn't have to go pull it or anything. It only started making changes at the point where I made a change in the container file, which speeds up the workflows, right? If I had put this all the way at the end or right before entry point, it would have done nothing until it got to that line, put in the Clumsy bird, and then did entry point. So now if you were to get a diff of these two different images, which you will if you pull them from a remote registry, you'll only be getting the stuff that changed, which speeds up the transfers for stuff like that. Okay, so let's clear the screen off. And I did stop the other one. Yes, I did. We're going to rerun our application pretty much in the exact same way that we did before. You can see again, we're doing a Podman run. In fact, I think this is identical. We're running the myHTTPD that we created, and we're calling it myapp. Everything's good to go. If we run this, it should do the exact same thing it did before. If I do a Podman PS, you can see my HTTP is up and running. I can't do this one with curl though, so give me a second here. I need to get my browser switched. Just a second here. Stop sharing this tab. I'll share a different tab. You're going to see a privacy error because I want to show you, just for the sake of clarity here, what I'm doing at the top of this screen that you can't see is I'm changing the URL, because what this was supposed to do was get me to the web console for this machine. That's what this security error is all about. But I'm just changing the URL. I'm taking away the HTTPS, changing it back to HTTP, and taking off the web console port. So when I hit enter now, we should get Clumsy Bird. There we go. So now we can actually...
I'm not the only one.
Yeah, right.
Bird.
I also don't play it that much.
Quick question. When
Sure.
you switch back to your terminal, what does the PS look like for your container that's running? Now, remember, we ran it as root, right? But who are the HTTPD processes running as out of that container image?
I think they'll be running as root, because I ran it as root.
Well, you see the question mark there for all the HTTPD foregrounds?
There.
Oh, they're running as Apache. Okay.
Oh, right. They'll run as Apache because that's what Apache runs as when it runs, right? When it when it brings up its worker processes, it runs them as Apache. So that makes sense. That's what it should be running as.
Yeah. And then we can see the question marks there for its terminal, because it's not bound to a terminal, right? It's running inside that containerized environment.
Right. Right. Now, I've been running everything in the background. There are cases where maybe you want to run something in the foreground. So for example, that UBI container. So if you do this -IT, which is interactive and in the terminal, instead of the -D that I did before, then what this will do is it'll run it in the foreground. And what was it? docker.io/redhat/UBI10, right? Now I actually get right there into the prompt. So if there's monkey business I want to do in the image, now remember, this is all within the state of this container. There are ways to make changes to this container manually and then write it back out. There's a Podman, I forget what it is now. There's a Podman command that'll say, take this container and write it back to the image that it came from, right? So you could do that if you want to manually build your container, or you could use Buildah. Buildah's another interactive way to build a container, right? So that's another thing. I think Podman Build is actually using Buildah in the background. It's just sucking in that container file instead of, to automatically build instead of doing it interactively. So yeah, this will feel a whole lot like a UBI or like a RHEL system, just like Scott was showing earlier in the Podman Desktop application. And once I exit, that'll be effectively I've closed the session and that container will stop. And because I use that RM command, it'll delete the container. So if I did a Podman PS now, you should have just the two we had running at the beginning. I already showed you how to get logs out of your container, but what if you need to actually get into the file system while it's running and troubleshoot something, or look for a path, or see where the permissions are set, or something like that? You can attach to an existing container and run a command within it. So if we do a Podman exec, we're going to, again, do this in the foreground interactively. I'm going to run, well, sorry, the container that I want to connect to, what did I call it? My HTTP. And we tell it what to run. Now, a lot of container images will sometimes include utilities that'll let you interact with the application. So, for example, the MariaDB container that we ran will have the MariaDB client tools in there too. So if you don't have MariaDB installed on your Podman host, which you probably wouldn't because it's a Podman host, not a database client, you can connect to the MariaDB container and run the MariaDB client to connect to the database to make changes to it if you needed to. So in this case, we're just going to run bash within my HTTPD. And there we are. We have bash up and running. Now it's very much like I'm inside of it's like I've SSH'd into my web host. So if I go to var www.html, I should find Clumsy Bird in here. And there it is, right? So this is the directory structure that you would have expected or that you would have found inside of that Git repository that I had pulled down. And there you go. There's Clumsy Bird. But, you know, if I started up Clumsy Bird and it's like, I can't find a file, right? I couldn't load the application because of something or other. I could connect to the container, go to the directory, and I don't know, look at permissions, make sure the file is there, make sure there's not something weird going on, just like you would if you had SSH'd into a system. So another useful way for troubleshooting.
All commands are basically the same in Docker and Podman, right?
So I have trouble saying all. There's a couple of very nuanced differences when you get into more advanced situations. For example, the copy command. Remember when I did the copy inside of that container file? There's a -- link option that works in Docker, does not work in Podman. So you have to work around that if you have a container file that leverages that. But for the most part, and I might even wager almost always, things are identical between Docker and Podman as far as how you interact with them. They may be doing things differently in the background, but you get the same result and you interact with them the same way. The same sort of Docker command line versus Podman command line, and container file versus Docker file being parsed by Docker versus Podman. Now, there are ways that you can bring, like you can take a Kubernetes YAML definition and parse that with Podman. As far as I know, you can't parse that with Docker. So there are things that Podman will do that Docker doesn't. But as far as I know, all the things Docker does, Podman does. That was a long way of saying mostly yes.
So there were a couple of things around, somebody asked about defining services. So I went ahead and linked a Podman and Quadlet episode that Nate did with Matt Myceni a while back. I think that's a great resource. And then we also have a lab exercise. So if you want to do a self-paced lab exercise on creating a rootless Podman service that Nate authored, you could try it yourself. And then somebody else asked about container files and expressed that they were a little bit unsure when it came to container files. So I took a container file lab and threw that in the chat as well. So looks like maybe we have some extra links to put in the show notes this time, Nate.
Seems that way. There's a couple neat things that we did not touch on. I mentioned the Kubernetes YAML files that you can parse with Podman, but there's two things that you may want to look into once you get past the introductory stuff with Podman. Well, three things. One of them is pods. Pods are like game changer as far as grouping services together. I run everything I run in Podman, I run in a pod, whether it's got supporting services or not, because I think they're easier to deal with. There's the Quadlet stuff, which Scott's already pointed to. There's also a system role for managing Podman, which basically allows you to take Ansible automation and use that to deploy and manage your containers and pods and services and volumes and whatever, including Quadlet, for Podman. So good stuff to look into once you get past the beginner level stuff. Once you're tired of dealing with managing all of your containers manually. And then once you outgrow that stuff, that's when you want to start looking at the bigger boys like Kubernetes and OpenShift, because you've grown into the point where you're doing enterprisey stuff.
Yeah, and Vincent asked a follow-up question: is Quadlet the right way to do service containers? And I think Quadlet is a newer technology, and the goal is to make service definitions much easier.
Okay, right. So I think what they're referring to is if I do a Podman generate systemd for, what did I call it? My HTTP. It'll spit out a systemd unit file, right? And I could literally take this, put it into a file, a service file, and put that into systemd, and then it will run this specific container using systemd. But you can see right at the top here, deprecated command. It is recommended to use Quadlets for running containers and pods under systemd. And the reason for that is Quadlet does it better. Quadlet is a systemd generator. So you tell it what it is that you want to run by name, and then it'll generate a unit file that runs that by name, right? Where what this is doing is it's calling directly by the container's identifier, how to start and stop this thing, right? So see, it's saying Podman start, and then that big identifier. The first time I delete this container and make a new one because I wanted to update it, all of a sudden, this is no longer valid. I have to delete my unit file or generate a new one, put it back into systemd. And that's what Quadlet is meant to solve. So if that was the question, then there's a deeper answer to it. Quadlet is the recommended way.
Right on. So I think that kind of runs us off our questions and stuff.
Cool.
Nate, what is a base image?
Well, I mean, every container comes from somewhere, right? Whether you're building your own base image or whether you're basing it on something else. And there's a bunch of popular ones out there. If you were unaware, though, Red Hat produces some for you. And that's exactly what we're going to talk about today.
Yeah, we're going to be talking about the Red Hat Universal Base Image, or UBI. You can get it from Red Hat's container catalog or Docker Hub. And we'll talk about how we maintain them as we move to the second part of the episode. All of our builds and demos today are going to be based on the Universal Base Image. So Nate, why don't we jump into the terminal and I'll just build a basic container off the base image.
Sounds like a good idea.
All right, so I'm going to use Buildah, and I'm going to do this interactively. I know that Nate likes to do things from container files, and he will wow us with that in a bit. But I'm just going to do a Buildah, and I'm pulling from the Red Hat container registry. That's why it's registry.access.redhat.com, but you can also get them from Docker Hub. In fact, when we switch, I'm going to talk some about the different options that you can use. I'll show you our container registry data, what it looks like over at Docker Hub. All right, so I did a Buildah from, and I told it what base container to use. And so it pulled it down and it mounted it at this location. So when I'm building my container with interactive commands, this is the container name I'm going to use to interact with it. All right, so the first thing I'm going to do for my web services container is I'm going to install Apache. So I'm going to do this Buildah run, because I'm going to run a command within my operating container environment. I tell it which operating container environment to use, and then there's 2 dashes that separates the Buildah command from the command to execute within the container. When we're watching this DNF install happen, it's being unpackaged and built inside of this mounted container image and container runtime that I've already got going. This is different based off the base image you select. If you selected a base image that already had Apache installed in it, then you wouldn't have to install extra software in it potentially. But UBI, the base UBI that I'm using here, we call it the standard image, has some software, but if you want to do things with it, you'll install your own software on top of it. All right. Then I'm going to do a couple of things. I'm going to make sure that when the container runs, it's going to run Apache. So I'm going to enable, oops, hold on. It's the wrong thing.
Just install Apache a second time. That's fine. Now, correct me if I'm wrong, but I think Podman, when I use a container file, is actually just using Buildah in the background anyway. So it's really more or less just there for people who don't like change, like me, to keep using their old container file.
And container files are really handy for things like repeatability in your builds, right? You don't want to have to copy and paste a series of commands periodically to do your container build. So it basically, usually a container file gives you that repeatability where you can just execute it and things just happen. All right, so let me try that again.
Well, I mean, we'll see in my later demo that you can just throw it into a script. So really, there's not much. Well, go ahead, finish your demo. We'll talk about that later.
All right. I configured my container so it'll listen on port 80. And when somebody hits port 80, they're going to get the init command, which is going to redirect them to Apache. And then I'm going to copy in my index file for my web content. Right? So I took my index HTML file, which looks like this. And I copied it inside of my container image, and I put it inside the container image at var www.html, which is where a web server would look for content. All right, the last thing I'm going to do is I'm going to commit my container. So what this is going to do is it's going to snap a copy of UBI working container, and it's going to call the resulting snapped copy LHTTPD. And so if I were to do a Buildah image list, I'll see that there's this container called ELHTTPD sitting out there. I can now run it. And I'm running it as root, which I know we all have opinions on, but I wanted to do something quick and easy for the critical path. So when I run it, I'm saying I want to run it detached. So I'm not going to have an interactive session for it. I'm doing a port mapping. So port 80 on the host maps to port 80 on the container, and ELHTTPD is the container that I'm going to be running, listening on that port. All right, so if I now do a curl on localhost, there's my super businessy website running from within my container. Right, I can podman ps, right, and there's my container that's running.
Super businessy.
Right. I picked UBI standard, which is just called UBI, because it's a multi-use image with things that one would need. But there are several other images, and we'll talk about how to work with those after the transition. Nate, any final parting words before we move to...
Question from Shantanu about there was a stat error, they said, in your output, and they're curious what that is.
There's a stat error in my output.
Yeah, I think it said something about not being able to find a file.
There's a typo on my part. So when I did my copy, I referenced this file name, but that's not what I called it. So I just took out the one, and then it was fine. And
I had missed that because I was trying to do other things like produce the show. So
yeah, there's that. All right, so don't forget to mash that like and subscribe. When we transition to the second part of the show, we're going to talk about the other UBIs. So there's 3 other ones besides the standard one.
We've got a whole family of UBIs.
Yeah, UBI Init, UBI Minimal, and UBI Micro. We'll talk about what they are and a little bit of differences between them and how one would work with them. When you go to the Red Hat Container Catalog and you look for UBI, and you see something similar when you go to Docker Hub, there's a whole bunch of different images. We currently build images for RHEL 8 and 9 and 10 beta. When you go to an individual one, this is the one for UBI standard, you can see a little bit of information about it. The information that I think most people look at first is this stuff. How big is it, right? So UBI is 85 megabytes compressed and 220 megabytes uncompressed. And if you look over here in the packages, this is literally all of the RPMs that go into this package. There are 1,535 RPMs that more or less go into there. That's not quite accurate because you can see that there's like different architectures, which wouldn't really be germane for all UBIs. It also shows you the packages. It gives you a Docker file or a container file on building stuff. All right.
That's handy.
And to get this image, you can download it. We mentioned before the break that there are more than one UBI flavor. So this is UBI standard, but if we look at UBI Init, which Nate's going to do a demonstration on in a bit, what's the difference between UBI standard and UBI Init, Nate?
So it's a very nuanced difference, but the core difference, right? Every container image has like a default command that it runs, right? So if you were to run UBI interactively, it'll get you to bash. The UBI init, its default command is actually sbin init, right? So it's actually both of these images contain systemd. UBI's is a little bit lighter weight. UBI inits is similar to what you'd expect in a full deployment, like a full RHEL deployment. But the big difference is how you run the container once you've put your application inside of it, right? So both of them would let you do a systemctl enable on a service. But then at the end of a UBI command or a container file or a Buildah, you'd have to tell it, okay, you're supposed to run init. Whereas with the UBI image, it'll run init automatically. I'll show you that when we do our demo of it.
And so you can see that the UBI init image is slightly larger than the standard UBI. And if we look at packages, it's got a similar list of packages, but there's slightly more of them.
There's a couple extra tools that go along with a heavier weight systemd. What it comes down to.
Right. All right. Then we have, that's bigger than UBI standard. Then we can go the other way and go smaller. So I'm going to do a demo a little bit later on this one, which is UBI Minimal, right? And so what you see is it's smaller, right? 38 megs compressed and about 100 megs uncompressed. But when we go over to the packages, it's got a lot less stuff. It does not come with DNF to try and save space. It comes with an alternate tool called microdNF, and that's part of what I'm going to be showing you today. To get it smaller, we give you less things.
Right.
And that's what makes it smaller. Less tools, less stuff built in by default. Can you install the things in addition to whatever your workload is? Yes. For UBI Minimal, you have to use a special tool called microdNF in order to do those installations. For UBI Regular and UBI Init, you just use regular DNF for doing that. And then you have the last one, micro. So micro is very small because it is like 7 megabytes compressed and 22.5 uncompressed.
Micro is like the size uncompressed as the other images are compressed, which is crazy when you think about it.
Right. And so the reason it's so small is because there are 13 packages.
There's like nothing.
Because the goal of this container image is to give you a bash shell.
Yeah.
And so it requires 13 packages, the 13th of which is bash, to get you a bash shell. And so it's a very Alpine-like container experience.
Right.
So there are no niceties. It's like, Nate, you probably like living in a house because you like have air conditioning and like temperature control. Right. You don't get wet when it rains and there's food in your refrigerator, right?
Yeah.
You've got all these modern conveniences. That would be like the normal UBIs.
Right.
UBI Micro is like if Nate lived literally outside under a tree.
If it's like you have maybe a cot.
No, not even.
Not even a cot. There's no cot. It's like you've rolled up some moss as a pillow. That's your bed.
Exactly. You literally have to do everything. You have to find your own food. You have to like get rained on. You have to build your own shelter, like everything.
But you still have air, which is really the requirement.
Yes. Yes. And I guess if it's raining and you open your mouth to get hydrated. We have this very minimalistic experience, almost identical to the Alpine experience, which means that you also have to build it very differently than you do the others. The others you can build with like, oh, I'll just DNF install this thing. Not here. Doesn't come with DNF. But Nate will be doing a quick demo of this a little bit later to show the starkness, severity, minimalism.
There you go.
Yeah. Honestly, Nate, when you build your container with this, are you going to hold up every package and go, does this package bring me joy?
I probably should. Shantanu compares micro to like IKEA, but IKEA at least gives you a screwdriver in the box, right?
Exactly.
Micro doesn't. You have to fashion a screwdriver from rocks and sticks.
Yeah. Here's the saw. There is the forest. Go forth and cut down your lumber and make your thing. That's kind of like what the family of UBI is. And over here on Docker Hub, that was my last tab. We also publish all these images over on Docker Hub. You can go to Docker Hub and find them. You can get information on like their size and all the normal Docker Hubbery things. There's some slight differences between Red Hat Container Catalog in terms of the metadata that's presented and Docker Hub. One of the big reasons why you use a base container image from somebody else is so that you don't have to manage it.
And that's kind of exactly why we have 4 different flavors of this thing, right? So that you don't have to go, oh, but UBI isn't quite right for me. Well, we give you 3 other flavors of UBI that might be right for you. And if they aren't, you could build it off of micro, I suppose, and make it exactly what you want.
Right. Well, but it also gives you one other thing, which is you don't have to worry about the software that comes with UBI, because we worry about the software that comes with UBI, right? So if you were building all of your own container images with your own software stack and a new version of Apache comes out because of an update.
Right.
If you're maintaining your whole container catalog yourself, you have to pay attention to Apache and know that an update was produced, right? Whereas if you go with something like UBI, Red Hat is paying attention to Apache. And so Red Hat knows that the update has been produced, and we will rebuild the UBIs to account for it.
Right, right. So I guess the other thing we didn't really touch on is that we've also got some images that contain not just UBI, but UBI with some common services on it, like UBI HTTPD, UBI MariaDB, UBI MySQL, right? I don't have the whole container registry memorized, but there's a bunch out there. And you can find all of those in that same registry that Scott was showing off earlier. So those would be even more applicable, right? So if you're just basing your container on UBI and then you're installing HTTPD in it, which is going to be our example over and over and over again today, you would have to remember to rebuild your base image or your HTTPD image whenever we release an update for Apache. If you're using the Apache container instead, the UBI HTTPD container, all you have to do is periodically make sure that you're updating your application container, and it'll just pull in those bits from us, and then you'll have the latest.
Yeah, and in fact, we have this thing called FreshMaker that makes fresh images, and it does so every 6 weeks. So we put all the updates into the UBI containers every 6 weeks, unless there's a critical or important security vulnerability in those packages.
I was just going to say, there must be an exception for criticals.
Yes. So if it's an important or critical security update that gets published, even if it's between the 6-week rebuild cycle, we will generate a rebuild mid-cycle to update the images and patch for them. That's the true power of base images, is make somebody else do the work, right? You manage your things, but make somebody else manage the operating system containery things that your thing relies on.
Right. You've got another demo coming up, don't you? For Minimal.
I do have a demo.
Or am I out of order? I think we're good. All right. You ready to do that? Here we go.
Sure, we can do that. I'm ready now. All right. The demo actually looks very similar to the demo I did for regular, right? Except for a couple of changes. One is when I do my Buildah from, notice I'm building it from UBI Minimal UBI image instead of regular UBI with no extension. This pulls the smaller UBI Minimal container. Because it was named UBI Minimal, I get a different working container name. All right, the other big change is to help make things smaller. UBI Minimal does not come with DNF. It comes with a different build of DNF called Micro DNF.
I was going to say, it sort of comes with DNF.
So it does all the things that you really care about with DNF, which is automatic dependency resolution and looking over multiple repos to find the transaction that it needs to put together across multiple repositories. So the core functionality of DNF is there. But when I run this to install my Apache web server content into it, what we'll notice is before it was like, oh, I'm going out to contact this repository and that repository and checking stuff. I don't get any of those output messages. And then we do things like transactions, and it has a status with hash marks where it shows me how long the transaction it is. Now with micro DNF, right? It's like, here's a transaction, here I'm doing the thing.
A lot of that output doesn't matter when you're in a container, right? So why include it if it's going to, even if it's just a couple of bits you've saved by changing the text output? But I'd imagine there's probably features of DNF, like, I don't know, rollback is an example I can think of, right? Or history. Like, I don't care about those in a container. So why would they be included? So I would guess that maybe things like that are what gets stripped out to really save space.
So I didn't check exactly those commands.
Right.
So I will not say, yes, that's exactly what happens. But you're right. We pull out certain functionality that is less core to DNF, right? The core thing is being able to look over multiple repositories, being able to configure multiple repositories, being able to do dependency resolution between.
Right.
All that is there in micro DNF. And then anything beyond that, like, that's a target for potential removal from micro DNF to save space. So that's it. From here on out, it looks pretty much the same as before. I'm going to grab my index HTML, but this time spell the right file name.
Good idea.
I'm going to configure my port. And then I'm going to go ahead and commit my image. But this time I'm calling it EL min. And then let me kill off my other container that I probably did not kill off.
Such a fun name to try to type.
Yeah.
You know, if you do a podman stop -a, it'll just stop all the running containers.
Thank you. That's great. All right. And then we'll go ahead and run my new container. And now when I do my curl, right, there's my super businessy website again, but now being served by a much smaller container with less software in it.
There's a question about SELinux inside of a container. Basically, do you need SELinux inside of the container? And I think there's labels that matter. But like full SELinux isn't running in there. It's depending on the host for that.
SELinux is implemented in the kernel.
Right.
The container doesn't run a kernel, so it's not doing Linux policy enforcement. But things like its file system and having SELinux labels on its file system and its processes so that the host's SELinux policies can be applied is what's important there.
And there was another one about, do we publish the recipes to create the base images, right? So like, can someone just download a container file or a Buildah script that would go and build them UBI?
Yeah, so if you look over in the Red Hat container catalog at the UBI containers, the Docker file that's used to build it.
So if you wanted something very similar to UBI, but not quite like UBI, you could grab this and customize it. But then I'd imagine you'd end up in a situation where that's not actually UBI. So any support that goes with it wouldn't be included because you've now modified it.
Like most things Red Hat, right? When you build something yourself, then you're committing to manage and support it yourself.
That's all stuff to keep in mind. It's the only reason I bring it up.
Right. And then talking about support, there's one more thing. You'll notice that when we look at the UBI images here, they all have a tag on them that say 9.5. So Red Hat will tag them with the version of RHEL that it was based off of. But UBI, because it's free and freely redistributable, lasts as long as a RHEL release active support, right? So when 9.6 comes out mid-year, we're going to stop building 9.5 because we're now building 9.6 images. And when 9.7 comes out, we're going to stop building 9.6 and start building 9.7. Recently, I had somebody ask me about, they gave me a 9.3 image and they said, it's not getting updates anymore. What gives? We stopped maintaining 9.3 images when 9.4 came out. That's why you're not seeing any updates, because we stopped maintaining that version of the image. And we tag it so that somebody can, like, if they're based on a specific version of RHEL, they can kind of align with that versioning.
That's the world you're supposed to live in with a container. You're not supposed to be afraid to apply those updates because you're supposed to be able to easily and quickly build a container based on the new software set, test it before it ever hits prod, and then fix your problems if there are any, which I'm going to guesstimate that there aren't going to be a lot of changes between 9.3 and 9.4 and 9.4 and 9.5. They're going to break your application as long as you're not doing anything super crazy.
Right.
But you have to change mindsets. Like, you can't handcraft, lovingly care for this particular container because that's not the world containers are made to operate in. They're made to be disposable. They're made to be quickly updatable. They're made to be quickly rollbackable. As I'm making new words today. So that you don't have to be afraid to do updates.
There are some things one could do if they had to operate that way. So in the example, I have this old container, I don't want to maintain it. It was 9.4. 9.4 is a extended update
Support
release. So you could download 9.4 container image. If it's running on RHEL that has the EUS channels enabled or repos enabled, UBI will use the hosts repositories. So you could disable the UBI repositories, only leaving the host repositories that are configured for EUS, and then you can continue to maintain that thing using the extended update support packages as time goes on. It takes a lot of intentionality, and you have to advance.
I'm going to say don't do that unless you have no other choice. Because that sounds like a nightmare. Because now it's all on you to keep that thing maintained.
It's not great. Just going to say, there's can we do it and should we do it? Can we do it? Yes. Should we do it? Probably not.
I think that's all the questions that I saw anyway. So next, I've finally got a demo. Bring up mine here. All right. So we talked about UBI, and Scott mentioned my container files here. So I made I forget the name of the directory. I put it in already. It's just called UBI-init. Okay, so we're going to open up this container file. And I'll show you the differences, right? So now imagine replacing these with the Buildah commands that Scott was using earlier. You'll have to translate that in your head because I don't have the Buildah commands to compare to. But what I'm doing here, now, somebody will probably see this and say, you shouldn't do a container this way because I'm doing two services inside of one container. I'm doing this for a couple reasons. One, because it is possible with this type of a container. It's not as easy to do with other container-based images. Sometimes you have a legacy application that you're just trying to get into a container. You really want to be able to run two services in the same container to keep things moving along, and this lets you do it. And it's one of the big differences between UBI and UBI Init is that you have this full init system with. So what I'm doing here is I'm basing my container on UBI-init instead of UBI. I'm doing a DNF install. I'm telling it to not install some extra things that we don't need, like docs. You're never going to shell into your container and look up the man entries for HTTPD. So we don't need to install those docs. Let's save that space. And we're also telling it not to install weak dependencies, which your mileage may vary. This may break certain things, may not. I don't know. Something that you'd want to consider. You don't have to do this one if you don't want to. And we're installing both HTTPD and MariaDB, right? We're going to put on the MariaDB server as well. Then we're going to clean DNF again. Then we're going to expose two different ports, 80 and 3306, which of course are both HTTPD and MariaDB/MySQL's port. The last thing we're going to do here, notice I'm not telling it what to run at the end. Right? This is not telling it to run this as the entry point or as the command for the container. This is telling it to run this command within the build environment. I don't do anything after this. And that's because of the way UBI Init works. So I'm just saying run a systemctl command to enable both HTTPD and MariaDB. And then I'm done. And the reason I'm doing that is because the big difference, in my opinion, between UBI and UBI Init is UBI Init has a more fully featured init, more fully featured systemd init. It by default will run spin init. So that's the core difference. We don't have to tell it to run init because it's going to do that by default. Now we're going to build from this. So Podman build -t is tagging the container. This is how you name the container. We're going to call it my init, and then the working directory to build from, which is the directory that I'm in. And you're going to see it go and do all those things. And then we're going to have a container image we can build or run from. And I'll run it and I'll show you that both of those things are running, although we can't do a whole lot with them because I didn't copy in a website. Like Scott was fancier than me in his demos. We're going to get the basic default Apache page.
Yeah, I put that effort in, Nate, so I could get super businessy website.
You did super businessy. So I did pre-pull the UBI images so we don't have to wait for those to download, but unfortunately we have to wait for the downloads of the packages. So that's just the way it is. Here we go. Shouldn't take too much longer. But you can see this is the difference here between the container file and a Buildah script. My next demo is going to use a Buildah script, right? It's through a bash script that I wrote so that I don't typo it. All right, it's done installing the packages. Next, it's going to run those commands and the exposes and whatnot that I told it to run. See, it created symlinks for the systemd services that it's going to start. Now, if I run a new container, we're going to run it in the background. We're going to give it a name. I don't know. Totally off the top of my head. It's super creative, my init container. This way I can identify it later. We're going to tell it to remove it when it's done. This isn't necessary, but I just want to try to keep Podman clean because I have another demo after this one. And then we're going to say expose these ports, -p. We're going to go 8080 to port 80. I guess I could use 80 since I'm running as root. And then we're going to do 3306. Okay, and then my-init is the name of the image that we just made. So we're going to run it like that. You can see now if I do a podman ps, there it is running. Right, you can see it's been up for 3 seconds. Now if I do a curl, $80.80, now we're going to get, uh-oh, what did I do wrong? Oh, 8080. There's the default web page from Apache. So yay, that much is working. But the cool thing here is that if I do a MariaDB-H, now remember, I didn't do anything with MariaDB. It has a basic config. There's no authentication set up. So it's going to reject me. You're going to see a rejection from MariaDB, which is the important thing here. Right. It's instead of saying it couldn't connect to the host, it's saying that it's not allowed to connect, which means that I connected to MariaDB within my container. MariaDB said, I don't know who you are. You can't connect to me. And it rejected me. So that means that both of these services are running within that container. Not usually the way people tell you should run containers, but if you have a reason to do it, you can do it this way with the UBI Init, which I kind of like. I like having options. How about you, Scott?
I like having one option only.
Only one?
Like the Highlander, there can be only one.
There can be only one option. So the next thing we're going to tackle is UBI Micro. Somebody said, I'll take these 2 demos and you can do micro. So here I am. Because remember, I said something like, wait, why are we using micro? That's the hardest one to do. All right. So here, I'll open up in Vim so we get some syntax highlighting. All right, so this is a Buildah script, right? And a Buildah script is really just a bash script that calls a bunch of Buildah commands. This is how I did it. We actually have an example that was written in the RHEL 8 days of how this works with micro, because that's when UBI micro came out and people were like, how do I use this thing? So here we are. What we're doing here is we're setting some variables, one of which is, hey, we need you to build a container using UBI micro. That's what this first one is here. It actually executes this command, which is really hard to read because it's red. I'm sorry. And then it puts the output into this variable, which we are going to use. Again, I think it's the name of the whatever. It's a pointer that gets me back to that particular build instance. And then we tell it we're going to mount the file system from this container that's running inside of Buildah externally to the host that we're running all these commands on, right? And that's important because remember we said there's no DNF in there. There's no package manager in there because what'd you say, 13 packages, Scott?
Yep.
How could I do, there's probably more than 13 packages that come in as requirements for DNF, right? So there's really no way that we could include DNF in a container image that tiny. You have to be able to install things some way, right? Now there's two options. One would be you have a compiled code base that you've compiled and you're just copying in, right? The other way is I'd really like to use these supported packages from Red Hat. How do I use DNF? Well, the way to do that is you use DNF commands and you say, use this other route for where you're putting the output of these commands. So we're going to put them into the root of the container that we just opened up inside of Buildah. So there's this running container image that Buildah's like, yeah, we're working on this thing. There's a virtual file system that goes along with that. And we're telling DNF, use that virtual file system instead of the host that I'm running it on. And then these commands run on the host, but they point to this other route, right? So keep that in mind. And then really we're just telling it what, sorry, go ahead.
So Nate, just a couple of quick things. So
Sure.
that micromount variable that you created,
Hmm.
all the other examples that we've used thus far, when we did the Buildah from and it created our working container, it had that mount somewhere. And so when we were using other commands, it was working with that directory. But we didn't have to specify that directory because we would use things like build a run and then the command we wanted to run within that environment.
Right.
But there is no environment other than a bash shell.
Right,
So
exactly.
all of our additional commands, we have to be like, oh, no, not in the host. And this command that I'm trying to use doesn't exist in the environment. So I'm going to run it on the host, but actually do all the file operations over there. And that's why we have to track that mount point. They got created automatically, but we didn't have to track in any of the other examples because we had nicer tooling.
So we're setting the release version, which is the same between my container host and my container image. But if it's not, you want to make sure you set this. In this case, I know it's UBI 9, so I'm setting the release version to 9. If you were building like a UBI 8 on a UBI 9 host, then that would be different. And then we're doing the same thing we did before. We're stripping out some things because this is a UBI micro. Why would we want to fluff it up with a whole bunch of extra stuff that we don't need, like documentation? So we're doing those same things about not including the docs and not including the weak dependencies. I have to look into a little bit more about what a weak dependency is. I guess these are probably things that are maybe not 100% required by the package we're installing, but are usually good to haves. Am I reading that right? I don't know.
It's things that are often installed together, but aren't
right.
absolutely required.
Right. Okay, and then we're just going to install HTTPD, right? Then we're going to clean out DNF, same way we did with the other one. Then we're going to do these Buildah commands to unmount that temporary directory structure that we mounted in order to do the DNF stuff. Then we're going to run some commands on this build. One of them is, what command do you run when you run this container? And that's just like in the UBI Init, how we told it, we don't care, just run init because that's the default. In this case, the default would have been bash, and we don't want bash because bash isn't going to run Apache. So we're telling it, run HTTPD and run it in the foreground, right? And then what port we want it to expose, 80 TCP, because this is Apache, and that's what it listens on. And then we commit all of it at the end, which again, these are commands that Scott was doing earlier, so these shouldn't be that big of a surprise. Okay, now we're going to run this. So we're just going to go micro Buildah. And it's going to do similar output to what we saw earlier, minus the MariaDB stuff, because we're not doing that here. And that's another key. There's no init system here. So you cannot, unless you were to install an init system, you cannot run two services inside of this thing. You'd be running exactly what it is that I called in that CMD as the run command.
Nate, after this transaction, we're up to 110 packages in a micro. And there gets to be a point where once you put all the stuff back in that you need, micro and regular UBI or minimal start to look really similar.
Yeah. Well, I have all these images. We'll do a Podman image list after we're done building this, and we'll compare. How's that sound?
Okay.
It's cleaning up DNF, and there we go. So now if I do a Podman image list, nope, image has an E in it. You can see I grabbed all the different UBIs because I wasn't sure which ones I was going to need for all my demos today. But so we have a good comparison of all of them here, right? So UBI Init is 251 meg. Now this is the uncompressed size, right? This isn't the compressed size. And you can see UBI Micro is 23.5, right? So pretty tiny. And now all I did was add Apache to it, right? And now here it is, 161 meg, right? Because you install software, it takes up space. The init one that I built earlier started at what, 251 meg. Now I installed two services here, Apache and MariaDB, and that's 619 meg, right? So you can see how these quickly add up when you're adding in all these different pieces of software.
And Nate toggle screen shares. I pulled up the same list for me.
Wrong share. What are you breaking, Scott? There we go.
This is why I can't be the producer. All right. So minimal was 102 megabytes natively. And then when we added Apache to it, it was 364. And regular UBI was 234. And when we added Apache to it, it was 451. Right. So UBI and UBI Init are pretty close. A couple hundred meg difference. So anyway.
Yeah, UBI Init are like, I don't know, 25 meg different. No, 15 meg different. All right. Well, let me finish up my demo here. Oh, you brought it back. Thank you very much. Okay. So now let's just run the container because that's the last thing that we can do here. Let's clear the screen off. Podman Run. Run it in the background. Give it a name. Wait, what did I call the container, Scott? I don't remember. It's called UBI Micro HTTPD. That should be easy enough to remember, right? Just a couple of dashes in the middle. Podman Run -D name. Just call it micro so it's easy to find later. We're going to put in that port 8080 to 80, and then we're going to do UBI. Nope, not YBI. UBI Micro HTTPD. And this should run it, right? Podman, there we go. We've got it up and running. Now if I do that curl command from earlier, should get us the same thing because we're on the same port. There we go. Same deal. But the container image is that much smaller, which to some people is super important, right? This means that it's going to be easier to do polls and whatnot for this container image. It's going to take up less storage space as you have more and more versions of it sitting around as your workflows are bringing in new versions of it. And all around, it's more efficient. So some people really care about that. And that's what micro is for, even if you don't, as long as you don't mind all the extra work it takes to build your images.
If you don't like living hard, like living easy, use one of the other UBI images. Again, minimal is less than 100 megs different once we have this.
Yeah, I think, honestly, now that I've worked with all of them, I've never touched micro before. So today was like the day that I learned how to use it. I don't hate it, but it sure is more complicated. I really think that minimal is a great middle of the road, right? Unless you need an init system or a more fully featured RHEL box. I think minimal is the way to make this stuff happen.
Yeah.
First of all, we're going to make a directory to store the data for this particular container in. We're going to pass that in as a volume when we start up our container. Okay, so we're going to start a MariaDB container. We're going to have it map in that volume, and we're just going to tell it to run. We've passed in some environment variables that are essential to starting up the MariaDB container with a user in a database. So we're just going to run this, and what should happen is it's going to pull in, and then it's going to run the container. So now it gave us this long identifier that tells us that it executed, right? It ran the container. So now let's do a Podman PS, right? If we do PS, it's going to tell us what containers are currently running within Podman. And the container we just told it to run isn't running. I told you this was troubleshooting, right? So we're going to figure out why it's not running. The quickest and easiest thing to try first is to simply check the logs for the container, right? So we do a Podman logs on the container that we just created, which we named MariaDB. If you notice up here at the top, I gave it -- name MariaDB. We're going to type in MariaDB. And you'll see the output. Basically, the last thing that this particular container image does when it starts up is run the MariaDB executable, the thing that runs the service, in the foreground. So any output from that execution should end up in the Podman logs. And most containers are built that way so that the useful troubleshooting information comes to the console if you were running that process in the foreground. We're going to look through the error output, and we're going to see here that it's pretty obvious. We've got a permissions problem. It says can't create test file, permission denied. There's a couple things that could cause that. I already see people in the chat guessing. I didn't set SELinux contexts. I'm going to show you the easier way to do that. So first of all, we're going to remove the failed container and restart it. All we're going to do is change the volume mapping here. We're going to add a :Z to the end of it. And what that tells Podman to do is the volume that we're going to map in, make sure you set the SELinux contexts on the local file system so that they are usable by a container, right? Now, we could have verified that by checking like the SELinux audit log, but I'm kind of going through the basics here. So if we do a Podman, here, let me clear the screen so you guys can see better. If we do a Podman PS now, should be running, right? It still isn't running. All right, so let's check again. You notice that the output is still really similar here. It's still giving us that permission denied error. So what might be the next thing that would give us permission denied? It's not SELinux. We already fixed that. You see here, the serve DB, which is what I passed in, already has the Containerfile T context set on it. So that should be okay. What about actual user permissions? If we just look at ls-l on serve DB, actually, no, let's do it at the serve level. We'll see, in fact, we see it there in the other output. It's owned by root and root. The thing about containers is whether you run them as root or run them rootless, the thing inside the container has its own permission set, right? So what you're running the process as inside of your container matters. If you're running that as a user inside a container, or if you're running it as root inside of the container, the permissions in the file system that you've mapped in need to match so that the user that it's running as inside of the container will actually be able to access those files. Now, I see Shantanu already suggesting that we should just chmod 0777. No, we're not doing that. That's the lazy way. That would probably do the job, but we're going to actually try to figure out what user we need to use. Now, there's probably lots of ways to get this done. The kind of quick and dirty way that I do it, we're going to remove this MariaDB container. Oh. Now we're going to clear the screen. Now we're going to run it again, except this time we're just going to knock off the volume mapping. So let's just take that out of there. And then it's going to run MariaDB with an ephemeral volume, right? MariaDB will start up. The container image will go into an ephemeral volume within Podman, within the directory structure that Podman stores such things. And then it should start up. So if we do a Podman PS now, there we go. It's running. But how does that help us find out what ownership we need? We can now get into the container and see what what ownership is on that directory in the container image. If we do a Podman exec, if you need to get into the container and look around, Podman exec is a great way to get that done. If you do Podman exec, and then we do the name of the container, we called it MariaDB, and then we just do bin bash. Oh, wait, you have to run that in the foreground. There's a flag for that. -IT is interactive and in the terminal. You got to put it in the right place. See what happens when I don't copy and paste, guys. I put stuff in the wrong place and it doesn't work. Now it should, there we go. Now we got it. Now we got bash. We're actually at bash inside of our container, the MariaDB container image. If I did an ls, if I typed it right, there we go. We've got a file system. Now I know that MariaDB lives in varlib MySQL, and that's where I mapped in that volume to, and that's where we need to figure out what permission should be set to. And if I do an ls-l, you can see there's a user called MySQL within the container that the ownership should be set to. If it's set to root, then the MySQL user, because it's not a root user, won't be able to write in that directory. But the problem with this is the host operating system, the place where we're running Podman, doesn't know about a MySQL user, so it needs the user ID. Now, there's other ways to get user mappings done And this is the way I've always done it. If we do an ls-l and then the letter n, it tells it to show us the numeric IDs for users instead of the names. Now we see it's user ID 999, right? And group ID 999. So now if I get back out of here and do a podman stop MariaDB, because that was just a troubleshooting container, right? We weren't going to keep that around. We're going to remove MariaDB, and then we're going to go to serve, and then we're going to do chown. We're going to do it recursively, so I need the -r, the DB directory. Okay, now if I do an ls-l, you can see it's owned by Yggdrasil, because apparently that's user ID 999 on my Podman host. Makes me wonder if MariaDB and Yggdrasil D would fight for ownership of that ID if I were to put them both on the same host. But anyway, I digress. And now we're going to run our container again with that mapping. Need to find it in my history here. That's the one without the mapping. There it is with the mapping. And we're going to run that. And now it should be working. All right, there we go. Now we have our MariaDB container up and running. If we look at the logs, now we get output in the logs that tell us things like, hey, MariaDB's up and running. I made my database and cool things are happening. So there we go. That's a quick rundown of some initial quick troubleshooting tips that I've got for Podman and using containers, especially if you're not quite familiar with what runs inside of that container. Now, there are ways to get metadata out of container images, so you could have gotten answers to some of those things before you ran it. I'm never that great at making doing all that research before I start a container, so I've had to learn all the tricks kind of the hard way. All right, so let's clear that, and then we're going to move along into our next topic. So there's another thing I learned about when I went through the Red Hat Certified Specialist in Containers training a year or 2 years ago. I didn't know you could do, but could be really useful in troubleshooting. When I did that Podman exec before, that assumes that the thing I want to execute is already installed within the container image. Sometimes that's not true, right? There could be, and the example I got from the training and the thing that I've used this for over the years since then is, what about netstat or SS, right? You won't always have that installed inside a container image. Remember, a container image, you want it to be as lightweight as possible. You don't want to install utilities that aren't required. In this particular case, the MariaDB container does have SS installed, but I don't see that often. Most containers don't have tools like that installed. There's a way you can take applications from the container host and execute them within the namespace of your running container. I wanted to show you that because I have found it to be super useful over the years. The first thing we're going to need is the process ID of our container process. So I am going to copy and paste because there's some formatting involved here that I don't want to have to type out live. So we're going to do a Podman inspect. And if you ever do Podman inspect on a container or a volume or any element within Podman, it'll give you output. We're also adding this -- format, and then this curly brace syntax tells it this is the element I'm looking for within the Podman inspect output, specifically the PID of this container. Once we have the PID, there's a tool called Nsenter, which allows you to enter the namespace of something else within a Linux system, right? Now, if you were running rootless Podman, you'll probably have to do this as root. So you'd have to use sudo to do this. You can still attach to that process because those are global, even though the root user wouldn't know about your user-based Podman containers. So you'd have to do sudo in front of this. But since I'm already running as root, we're just going to use it without sudo. So nsenter, and then we do -n and -t. I forget what those stand for, but those are the flags you need to make this work. And then you need the process ID of that container. Now, you could take that Podman inspect and take the output of it and directly interpose it into your command or make it a single command instead of two. But I wanted to show you the Podman inspect command separately. So what was it? 13214. And then the command that you want to run. Now, what this will do is it'll take the executable, the SS executable from my host and execute it within the namespace of that process ID, 13214, and then it'll give us the output, right? If I just do SS TULNP is my usual syntax for, or my usual command line options for SS. Yours may vary. And there you go. It's telling us that it sees a process listening on port 3306, which is exactly what we'd expect. You might ask, wouldn't you be able to get that from the Podman PS output? And you can see, yes, you can. There's a column here that says port. But what that's telling you is the metadata for this container image has told Podman, this is the port I listen on. That does not necessarily mean that the service running within your container is actually listening on that port. That's just the port that the metadata says. Now, if you can trust the metadata, and if everything's working as expected, then yes, that should be the port that your service is listening on. But what if you made a configuration change to the service to change the port, or passed in a configuration file that changed the port for some reason and you didn't realize that's what it was going to do? This will help you troubleshoot that, right? So you're like, why isn't it listening on 3306? It says the service is up. Why doesn't it work? This is a good way to troubleshoot and verify. Is it in fact listening on the port that you expect it to be listening on? So that, like I said, not something I use frequently, but it is definitely something that's been valuable over the years to be able to do that. And you don't have to use this with SS. You can use it with other utilities. SS is just a great example because it's pretty self-contained. I've tried to use this for things that do disk operations, and that doesn't work because the disk operations get confused about being outside of their namespace. I forget exactly the nuance there, but that didn't work properly for me. Other things that just sort of read state out of memory, they work great using this feature. So there you go. The next thing I wanted to talk about was, can you run more than one service within a container? We did talk about this when we were talking about different UBI containers. The UBI has a variant called UBI Init. And what that does is it is set to run init as the thing that it runs when it executes. So when you're working with UBI Init, what you do is you install services and then use systemctl to enable them. Now, you can also take the standard UBI containers and make the command line sbin init, and it'll do the same thing, or similar anyway. If I remember correctly, the systemd and the two of those are slightly different, nuanced different, but they both get the same job done. But I'm going to be using UBI init in this particular example. Let me get to my notes here. And I'm going to, just like we did in the first example, let's clean up a little bit here. Let's remove that MariaDB container so it doesn't confuse us at all. Podman PS is empty now. Everything's gone. Good. We're going to make a directory. We're just going to call it my container. And we're going to edit the container file within this directory. Now, if you've never built a Podman container from scratch before, this may look a little foreign to you. But basically, Containerfile is synonymous with Dockerfile. I could have made a Dockerfile instead of a Containerfile. Podman won't care one way or the other. You could probably name it whatever you want, just point it at the right file. But Containerfile or Dockerfile are the ones that Podman will look for by default. That's why I named it that. So we're going to paste in the container file that I have pre-composed. We're going to start from UBI Init, the RHEL 10 version or the UBI 10 version. We're going to install MariaDB server, and we're going to install HTTPD, and then we're going to clean out the DNF cache because we don't need to carry the DNF cache into our container image. All that does is make the container image larger. There's a lot of attention paid to how big these container images are because the bigger the container image, the longer it takes for it to pull and deploy, the more traffic that'll cause on the container registry that you stored it on. You just want to be cognizant of. And then we're going to do a systemctl enable on both HTTPD and MariaDB, right? Now, we're going to save this, and then we're going to build this container image. We're going to give it a name of my container, and we're going to give it the build context of the current working directory, just dot. So you could say, if this was in a subdirectory of where you are, you could say / container directory, whatever, right? But anyway. This is going to pull in UBI Init, and then it's going to build our container out of the UBI Init. Now, you notice that the UBI Init didn't pull nearly as much. That's because they share the same base, right? So they start from the same base image, and then the UBI extends that. Some of those layers were the same, so Podman didn't pull them again, and that's actually pretty handy. Now we've got it built. If I do a Podman image list, you'll see we've got a localhost / my container right here. And now if we run that container, just copy paste this one as well. So we're doing Podman Run -D says to put it in the background. I'm going to give it a name, my container test, and we're going to run localhost my container. That's the image we want it to run. Notice I didn't pass in any volumes because this is just a test, right? If this thing were going to persist, you'd want to put in some web content that actually talks to that database and put in persistent storage for the database. Otherwise, all that's going to go away as soon as you delete and recreate this container. Now, if I do a Podman PS, you see we've got my container -test up and running. Let's hop into that container using Podman Exec like we did earlier. My container test, and we'll do bin bash, right? And now we have a shell inside of our container. How do we check if the service that we told it to run are in fact running? We do it just like we would on any other Linux host that runs systemd, systemctl, status httpd. And you'll see here that, in fact, httpd is up and running, right? Good to go. And then if we do the same thing for MariaDB, you'll see MariaDB is up and running. Now, because they're inside of the same container image, that means that you have a web application that needs a database backend. They can talk to each other locally within the container, right? Now, that has some benefits. Maybe you have this legacy app that you don't want to break these things apart, and that's the way it runs in production today. Maybe you just want to take that thing and encapsulate it into a container and put that into a container host. I can essentially treat UBI very much like I would a standard Linux host. I can configure it the same way. I can put my config files in the right places, but I get the portability of being able to treat this thing like a container. I can put that into a container registry. I can put it out across several systems if I needed to. I can map in dynamic data or persistent data, and the thing operates like a container now. But it's not really following container best practices. The best practice for a container is to make each one as small as possible and make it do one thing really well. So in this case, we have this kind of larger container that does two things. You could argue it doesn't do either of them really well, because you can't then take this container and tailor it specifically so it does nothing but HTTPD and nothing but MariaDB, right? You have to make it so that it does both, and your container gets larger and more unwieldy, right? So there's reasons you might do this. There's also reasons that maybe you shouldn't. This is just my opinion, right? If you want to do it this way, it's up to you. One of the nice things about containers is that if somebody were to compromise, say that web application is this big convoluted, dynamic web application that's using an interpreted language like Python or PHP or something, and some attacker finds a bug and breaks out of your web application and into the host operating system. Well, in this case, the host operating system is going to be inside of that container. Your database or other private data that you probably don't want them to get access to is also inside of that container. That means they can try to get across from the compromised system or compromised application into the backend data, which might have more sensitive information in it, which you don't want them to have access to. If they were running in two separate containers, then if they break into one, the only way they get to the other is by the TCP communication between the two containers, which makes the attack surface smaller. Keep in mind, if you're going to try to do something this way, it's like running your web app and your database on the same host, kind of bad practice, right? Consider yourself, can Podman pods replace Compose? If you work in a Docker world, you probably work in a Compose world. With Docker Compose, you get this YAML file. And it's an easier way to define a grouping of containers that form up an application. And then you use Docker Compose to start up your application as a unit. You can define the volumes that are required, what networks are required, and all of that within the Compose file. And then you can start and stop the whole thing with one command. You bring the app up, you bring it down, you can redeploy it. There is a tool called Podman Compose, though there's a better way to do it with Podman. that training I told you about did teach me how to use Compose with Podman. So I did learn it. I think there's a better native way to do this with Podman, which is using Podman pods. And then you can extend that into this redeployable YAML file. I have another demo that'll show us exactly how we do that. So I'm going to go start to finish. How would I make a pod and then make it redeployable with one of these YAML files? The way I normally do this is you'll go to some public project, right? And they will provide you a Compose file because that's how they assume you're going to deploy this thing. What you have to do is take that Compose file, and I believe there are tools that will convert a Compose file for use with Podman. I never do it that way. I always read the Compose file. I understand what the different things in the Compose file are trying to do, and then I manually build a pod based on that Compose file. But don't worry, that's not where it stops. I'm not going to say that you should just manually build all of your Compose files into a pod in Podman. That's only half the answer. So first, let me show you how you build a pod and how you put containers in it. Let's clean up again. These commands, if you're not familiar, this says stop everything and remove everything, right? So if you're on a Podman host and you've been tinkering around and you want to clean it up, do that. It'll stop all the containers that are running, and then it'll remove all the containers that you're running. So now if I did a Podman PS, you'll see there's no containers running. And if I did that with a -A, it'll still say there's none running. -A will tell you if there's containers defined that are stopped. Okay, so first let's make a pod. And we'll just call it my pod. Podman pod create, and then we give it a name, my pod. If you're making a pod, you're probably going to want things to be able to access the services inside of there. And the way you do that is very similar to how you would in a container. Let me show you. Let's remove that one. Podman pod rm my pod. Let's say I wanted to pass port 80 in there. We do a -p 80, hold on, 80:80. And what this would say is pass port 80 into the pod, right? And then when I bring up a container that uses port 80, that's the one that's going to listen. That's the one that's going to receive that request as it comes into the pod. So now I have the pod created. Let's put some containers inside of the pod. So first of all, we're going to put a HTTPD container in there. And this run command is going to look pretty much identical to if you were running any old container, except I'm adding this --pod subcommand that says link it to this pod. And if I had a volume to map in or something, I would do that here, but I would not specify ports that I want to pass along, because normally you would do that with a container. I did that at the pod level. The pod will be able to access whatever ports your containers listen on, but the pod works as a boundary firewall where it says, okay, ports that I don't care about, they don't get into the pod. Ports I do care about, go to whatever container is listening on a given port. I'm going to run that one. We're sticking with a similar example to what I did in that multi-services container build. The next thing we're going to do is put our MariaDB container, the exact same one from earlier, inside of this pod now. You can see we're going to do a Podman run. This is the exact run command we did earlier, except I'm adding the --pod, my pod, right here. So you can see where I have that added in here. Otherwise, this is the same run command we used to run the container earlier. It just gave us that ID back. That means that it's running. If I do a Podman PS, now it shows us we've got the MariaDB container running, and we've also got this infrastructure pod. You see this localhost /podman-pause. This is like an empty container that simply runs the network pod containerization that goes along with making a pod, right? The thing I like about Podman pods is now I can treat the containers like an individual entity. All of these containers that make up a service, the web service and the database backend, are grouped inside of this thing called a pod. I can do things like start and stop that pod. It gives me this status here. See, it says status running. If I had defined health checks for those containers, then if one of them failed their health check, it would tell me in this status. If one of those is down, did I just call it HTTPD? Yes, I did. If one of those containers is down within my pod, and then I do a Podman pod PS, it tells me it's degraded. and it'll tell me that there should be 3 containers. Sorry, but it tells me it's degraded, which means that there's a container that it expects to be running that is not running. Now I have one of my containers down. I can do a podman start, or pod start, sorry, on my pod. And what that'll do is, oh, if I typed it right, I saw a comment before we started the show about somebody feeling comforted when we do typos on the show. So you're getting plenty of that today. My pod. Okay, so we're going to do a podman start my pod. And what this will do is it'll say containers that are within my pod that aren't started, go ahead and start them up, right? And now, assuming there wasn't a problem with that container, it'll start up and it'll say it's running. I run into this sometimes where if I have 2 or 3 things that are dependent on each other inside of a pod. The last time I looked into this, Podman doesn't really give us a way to define dependencies, right? So this one has to start before that one, or this one has to pass a health check before that one. It just isn't that advanced. Sometimes I'll run into a case where the pod comes up, the one thing comes up before the other when it should have been the other way around. Because of that, one of the containers within my pod fails to start. And the easiest way to fix that, once you've identified that's the problem, is to just do a podman start on the pod and up it comes. So for applications I have that commonly have that problem, I just have a script that runs every so often to check the status. It'll rerun the pod or rerun the containers that were failed. If that fails, then you know you have a bigger problem. So we can also restart on the pod, right? So if I did a podman pod restart, it's going to go through and it's going to stop all the containers and bring them right back up again. If I did a stop on the pod, it'll also stop the pod, right? You have to go into the pod subcontext, right? And if I do a podman pod PS now, you should see that it says exited because we cleanly shut it down. But this only gets us part of the way, right? This gives us a unit within Podman that we can treat our entire application, including all of its dependencies, as a single unit, which is great. But it doesn't make it redeployable. The one thing that's really cool about Docker Compose is you can take that compose file, and as long as it's written in a generic enough way that it's compatible across several systems, that's not always true when you're doing things like defining volumes, but you get the bulk of that application defined in an easy-to-read YAML file, which you can then make the little tweaks that are needed for your particular systems. If all of your container systems are designed the same way, it should mean it's portable from one to the next, or if you have it map in volumes that are on a networked volume instead of local. But making an application into a pod doesn't get us that. So there is a tool that'll help us do that. And it's not even a tool, actually, I should say. It's a feature of Podman. We can tell Podman to generate certain things. For example, I can tell Podman to generate a systemd unit for a container so that I can then plug that into systemd and it'll start that container every time I start my machine up. Or I can interact with the container through systemctl instead of directly through Podman, which is helpful when you're trying to sort of enterprise up your containers, right? There's a tool we're not going to talk about today, but something you should be aware of called Quadlet that'll also do that for you. You can make these YAML definitions in Quadlet, and then you can deploy stuff that way too. It'll generate a systemd unit. Systemd can then start up your containers. With Quadlet, you can also deploy an entire pod using a YAML definition, which is also something that Podman can generate for us. So if I do a podman generate Kube, K-U-B-E, because this is compatible with Kubernetes. I tell it what to generate on my pod. We're going to do it against the pod. And it outputs it to the screen here. Here's the pod. This is what this would look like in this YAML definition. And the cool thing about this definition is that I can now take this and move it to other systems. But this just outputted right to the screen. So -- file name mypod.yaml says output this to a file instead. And now we can open this up in Vim. And now we get the benefit of syntax highlighting. Some of this metadata isn't necessarily important to include in your redeployable files, like the creation timestamp. It's good information to have if I'm versioning these things. This is defining an item that is a pod. It says kind pod right here. And it's got this metadata. And you can see that it's got a mention of our binding, our mount binding in here. If we go down, you can see where it says labels, the app, and the name. This tells it what to call the pod when you deploy it, right? Using that syntax, you could change this if you wanted to. If you're deploying several of the same thing, you just change that name and it should come out the other end with a unique name. Then it goes into the actual definition for the containers, and each of these are an array within the YAML definition, right? So you can see here the environment that I had defined, and there are ways to take these environment variables and move them to a separate file, or you can use secrets instead of putting these things in here plain text. Again, I'm not delving into that today. And then we've got our MariaDB container, and it tells it what, sorry, I should say we have the HTTPD and then the MariaDB container. And then, of course, here we have those volume mounts, right? So there's a block within the MariaDB container that says, this is where you're going to get varlib MySQL from. And it uses an actual, it's very similar to how a PVC works in Kubernetes, right? A persistent volume claim. It defines the volume separately down here instead of just this directory mapping, right? This is just how the YAML makes it happen. And then down here is a host path that says mount/serve/db and serve db host 0. And then it says to take the volume called serve db host 0 and map it to varlib MySQL within the container, right? We're going to remove my pod. And what this will do is it doesn't just delete the pod definition. It actually gets rid of the containers that are within it, right? And now we have no more pods. If I do a podman play kube on this file, this mypod.yaml, what it'll do is it'll read that YAML back into Podman and redefine all those things within that YAML file. And now we have my pod back. And the containers within my pod. When you bring it in this way, it names the containers so that it's not going to be easy to accidentally get container name conflicts. It names them all with this. It puts the name of the pod and then a dash and then MariaDB, right? So this is a thing you might want to keep in mind as you're defining the container names. Otherwise, you're going to end up with these crazy long container names that if you need to work with a container name directly, it gets a little unwieldy. All right, and the comparison here to Docker Compose, it's different. I have seen a couple of projects that are publishing Docker Compose files are now also publishing these definitions because these can be modified and used in Kubernetes as well, right? And that's also a thing that a lot of these projects were already doing. So now they're just making one more slightly stripped down version of the same file to let you deploy this stuff in Podman. I think it's really handy that they're starting to support more than just Docker. I'm going to start with some basics, but the goal here is to talk about how to serviceify or maybe even run Podman in a way or Podman containers in a way that it's a little more friendly to important services that an enterprise might care about instead of just something you're tinkering around with on your laptop or in your home lab. While the Kubernetes and OpenShift platforms are awesome for truly enterprise scale containerization of applications, there's a niche in the middle where you don't quite need that sort of a heavy solution, but you still need to do some containerization. And that's where Podman fits in really well. We're going to start with some basics. And that is, we're going to just run a container to refresh everybody's memory. Give me a sec here to get my scene right. There we go. I have just a basic RHEL 10.1 system here, and Podman's already installed. We're going to start out by running everybody's favorite demonstration, which is to run an Apache container, right? And within Podman, this works. Anyone who's ever used Podman and maybe came from a Docker world will recognize that these commands are pretty well identical to what you would run from a Docker command line. And that's on purpose, right? It's meant to be interchangeable. It even runs all the same container images that you would in Docker. So let's go. So Podman Run tells it we're going to run a container. We're going to give it, we're going to run it as a daemon in the background. Detached mode is really what that means. I always confuse that with daemon, but it's not a daemon. It is simply detached. It's running in the background. It's a detached process. We're going to give it a name so I can find it later. I'm just going to call it HTTPD. We're going to pass a port into it. Port 8080, we'll go to port 80. And what this tells it is that the container runs the Apache service, or the HTTPD service, which listens on port 80. Now, it doesn't have to listen on port 80. That this container could be configured that Apache listens on 85 or 8080 or whatever. And you have to know that. And that's all stuff you can get out of the metadata of the container. Once it's running, you can log into it and do some inspection to figure out what those ports are. But usually those are published by the people who made the container. So they try to make that as easy as possible. In this case, we're going to pull HTTPD container directly from Docker Hub. There is a RHEL version, there is a UBI version, but I like to use Docker Hub to show you that you can use the same container images that you would use if you were using Docker. So we're going to do this, and I had already pre-pulled this so that we didn't have to sit here and wait for it to download. But what it would have done is it would have went to Docker Hub, pulled down the Apache container, and once it got it, it would have then ran it. So if I do a Podman PS, then this will tell me what's running inside of Podman. And you can see right there is my HTTPD container. And we can use curl to just, yep, if I type it right, on port 8080, right? So we're using curl to connect to localhost on port 8080. This will be accessible from outside of this machine as long as we have the firewall configured to allow port 8080. You can bind a Podman container directly to an IP address. If you wanted to bind it only to localhost, you could say bind this to localhost. If you wanted to bind it to a specific IP, like if you have several IPs mapped to this machine, I do that in my home lab. I have a one hypervisor / container machine that I have a bunch of IPs assigned to, and then whenever I have a service that needs to run on a specific IP address, I map in an IP address and then I bind the container to that IP. So I know when I want to get to Plex, for example, it'll always be on the same IP address. So that's easy enough, right? We can run a container, feels just like if we ran a container in Docker, which is pretty cool. Personally, when I run an application in Podman, I like to put it in what's called a pod. Docker, I haven't looked at Docker in a long time, but when I left it, they didn't have the same concept of a pod. They had Docker networking, and Podman also has Podman networking. But what a pod does is it groups containers together, and it also maps them into a network and namespace, right? So I like to put things that have several services, like if there's an app and a database and a message queue or whatever, and they all need to be run to support that application. I like to put those in a pod, because then inter-container networking happens within the pod, but anything that's coming from outside of the pod can't get to anything I didn't map to it. Now, to save time today, I'm not going to show you how to make a pod from scratch. We have other episodes about that. There's one where I talked specifically about pods. That's something that you can go back and watch if you want to. I didn't want to do that today. I'm going to skip straight to what I like to do with pods, which is once you have one defined, you can export it using Podman Generate into a YAML file. And that YAML file is very much like a Kubernetes definition for your pod. A pod is a concept that Kubernetes uses as well. So you can define pods using YAML in the same way that I'm going to show you in a moment. And then you can bring them into Kubernetes, and then you can run your pod that way. I like this because if I ever move to a world where I am using OpenShift or Kubernetes, I'm already partway there because I have these pods all defined and I have them set up inside of YAML files that I can use in Kubernetes. Let me clear the screen here. We have a wp-pod.yaml. Get to the top of the page here, top of the file. If you watched our episode on Vim, you know what shortcut I just used to get to the top, or one of several that you probably could use to get to the top. I used 1G if you care. Okay, I'm not going to bore you with every single thing that's in here, but you might guess if you read through this, we're going to run a WordPress application. And I like WordPress because it's really easy to set up and run, because it's made to be easy to instantiate. It's also got a web application and a database. So it's a great example for what you might use in a pod. I've got two containers defined in here. One of them is the database, and that's a MariaDB database. You can see the image right here that I'm using for that. And then there's some environment variables passed into it to tell it what its password is and all of that stuff. And then down here, we map a volume into it so that the database has a place to write its files out, so that when the container goes away and comes back, it doesn't lose its state, because a database that doesn't save its data isn't very useful. And then we have WordPress down here. There's a container published for WordPress on Docker Hub. We're going to use that. And we tell it what ports to map in. In this case, I'm going to use port 8081 because we already used port 8080. So we're going to use 8081 here. There's some other security context information that was generated when I usually make these pods manually, and then I export them using Podman Generate. These are things that Podman pulled out of that definition. So I left them in here because I figured it knew what it was doing. And then, of course, we got volumes for that. And then at the bottom, we have all the volumes defined here. And let me just fix this because I was puttering around before our show here. I'm going to fix this here quick. So give me just a second here. Sorry, my second machine that I'm going to use for a demo later has locked. That's going to be fun to deal with later. Okay, let me fix this. We're going to put it inside of my home directory. Home, Nate, containers, WP content. We're going to fix this one here too. Okay, and those are the only two volumes that I have defined there. Now, I also need to make those directories, right? Podman won't make them for me. It can auto-create the SELinux contexts. That's what this :Z is here, where I have this defined. That says if the contexts aren't right, set them. I'm not going to have to worry about setting the SELinux contexts, but if you don't use that :Z, then you will. It's Container_file T, container_file_T is what you'd have to set them to. I'll show you a little bit about that in a minute when we get to the automation piece. So now that that's saved, let me see here. I think I had the directories we needed to create in my notes here so I could copy and paste, but I don't see them. So we'll do it ourselves. /containers. Wow, can't type. And okay, that should make both directories. The directory structure is made now, right? There's the WP, and then inside of there should be the database and WP content. And then we're going to build this pod out using Podman play and then Kube, because that's the type of thing that it's going to bring in and export. And then this file here, this wp-pod.yaml. And what this will do is it'll read all that in. If it didn't already have the container images, it would have pulled them down. And then it runs them as a pod. If I do pod ps, now you're going to see there's WordPress running. If I do podman ps all by itself, you'll see there's containers for all of the things that were in the pod. Plus there's a container for the containers called an infrastructure container, which is this guy right here. So basically when you start a pod, it'll always run the number of containers you've defined plus one, right? So it'll be, in this case, we have two actual applications that are running inside of there. There's the web application and the database. And then aside from that, there's this infrastructure container. Now, let me unlock my laptop over here. I thought I had told GNOME to not lock, but it did anyway. Let me switch my share and I will show you that this is working. So give me a second here. It's going to change my scene on me. Fix that. Okay, so this is, hang on. So remember, it was 8081 that I set it to. These are just IPs in my home lab, so nothing you'll be able to get to. But there you go. You see, we've got the WordPress setup screen, which is exactly what I'd expect, because I didn't give it a database. I didn't give it content, although you could have, right? So if you were moving this from one machine to another, all you would really have to do is get that YAML file and all of the data that was inside of that directory structure that I set up, move it to a new host, and then you would use Podman Play or some other thing that would bring the YAML into Podman, and then it'll run the container or containers. It'll bring in the data that you mapped in, and then it would run the application as it was on this other machine. All right, let me switch back here. There we go. I figured out the incantation to not make it reset my scene on me. Okay, so what I'm going to demonstrate one flaw of running containers manually in Podman. If you're coming from the Docker world, you will recall that Docker runs a daemon, right? Which means that whenever you run a thing with Docker, it goes through that daemon and it runs as the user that the daemon runs as. This could be a thing that Docker has improved over the years, but that was always one of the core differences between Docker and Podman. It was this daemon. You notice I did all these as me. These are not as root. So these are all running inside of the context of my user. Connect to my WordPress site, break out of the application, get to a shell or something within the container, then break out of the container. They would still be limited to my user on this machine, which in this case wouldn't be great because this user has sudo. You could assign these containers to users that have absolutely no privileges on your machine, and then all they do is run the container, which is actually a really nice thing. But the downside of not having that daemon is if I reboot this machine Oop. When it comes back up, those will not be running anymore. And I do this specifically for effect. So let's give it a moment here to reboot. Let me look at chat here quick while we're waiting. Does Podman have any functionality / shorthand to specify IP of ETH2? I don't know. It might. I always just do the IPs directly. So maybe there's a way to specify an interface. Will you be going over HashiCorp? No, I don't really have anything to talk about where it comes to IBM and HashiCorp. So sorry about that. HashiCorp is not a thing that I'm all that privy to. You ever had the beard set to red? I have. It's been red, it's been purple, it's been green. Now it's kind of a faded blue. Podman does have a restart always, but I don't know that there's a way to get it to work in the same way that Docker does. When Docker, if you say restart always with Docker, then when the machine boots and the Docker daemon comes up, it'll automatically start that container up. If you set restart only in Podman, if the container dies, but Podman still knows about it because the machine hasn't rebooted, then it will automatically bring that container back up. But I don't know that it'll do it at boot time. Maybe someday I'll try a little more and see if that status has changed. Okay, let me put in my SSH key password. We're back up and running. Machine is booted. Let me clear the screen. If I do a Podman PS, you see now nothing's running. My pod is still defined, but it's exited, right? So if I did a Podman PS-A, that says show me everything. You see that they're all still defined, but they didn't start up. Podman integrates really well with systemd. There's a couple ways to get that done. The one I like is a tool called, or a feature perhaps, called Quadlet, right? So give me, yes, there's a comment in chat that there's a Podman restart service now that'll do that for you. So that's also good to know. Thank you for adding that comment. I don't generally use that because I do it the way I'm about to show you. There's an even better thing I'm going to show you after that. What Quadlet is, it's what's called a systemd generator. And you can define these files that Quadlet will then parse and write systemd unit files for. So what I'm going to do is show you how that works out. I wrote them beforehand here. So first of all, let's look at our simple HTTPD container. Okay. So this, you can tell already, this looks a whole lot like a systemd unit file, but it isn't quite identical. This block here, container, that's not a thing systemd knows about, but that is a thing that Quadlet knows about. So I can make this definition and, description, that's just a human readable name, but this stuff here is what's important. We've got image, and it tells it what image we're going to run. So remember that command line we ran earlier. We gave it the image name. We gave it a name, which Quadlet will infer from the name of the service. We gave it a port to publish. And another thing that you very commonly do when you're running a container is give it some environment to pass into the container, because a lot of container images will read configuration out of the system's environment and run the service according to what your environment is set up to do. So the Quadlet gives you the ability to do that, right? You can say, here's my environment variable. The variable here would be some var, although I typoed it, there's a D at the end, but you get the idea, equals, and then whatever the value for that variable should be, right? And then that would pass into the environment of the container, which is super useful, right, to be able to get that done. And just like environment, there are directives in here under the container block that would do all the things that you would normally do on the command line. I just put in a couple examples here. Like I said, publish port, right, that -P that we passed it, 8080 to port 80. Let's go ahead and close out of this. Now, you can run Quadlets as a user. Unfortunately, I didn't prep today's demo to run the Quadlets as a user. So systemd has this concept where you can make some directory structure within your home directory, and then systemd will know to look there, and it'll start the services as your user. So if you were trying to run containers as a user, you can still do that with Quadlet. I just didn't prep that for today's demo. Just know that that exists. So what we're going to do is we're going to take this HTTPD Podman container, and we're going to copy it to etc containers systemd. Okay, sudo. All right, now once I've copied it there, I can run Quadlet in a dry run state. right? And what that'll do is it'll run the generator and output to the screen what it would do if I were to make it do it for real, right? So if we do sudo user libexec podman quadlet -- dry run, you can see that what it outputs here is a unit file for httpd called httpd-podman. That was the name of the file we put in place. That's where it gets that from. And then you can see it expanded all of this out to be what we need, right? What we would be defining, right? You can see there's this new directive that says x-container. It tells it how to run the service. You can see here that what it does is it runs the service. That's the stop command. The start command down here, it says Podman Run, gives it the name, tells it to replace it if there's one that's already there. It tells it to remove it when you stop it. One of the features of Quadlet is when I start or stop one of these containers, it makes it brandy new, right? So if I want to update my container, all I have to do is stop the service. It'll destroy the whole container. Like it'll completely undefine it from Podman. And then the next time it starts, it'll go and check fresh, go get the latest version of that container and run it, which is really useful because it makes it a lot easier to update your containers, right? You don't have to really think about it. You don't have to think, did I download the latest version or not, right? Because it makes a new one whenever you restart that service. So now that we have it there, let me get back to the top here. Oop, sudo is spelled wrong. Yeah, systemctl. If we do a daemon reload, this is the same thing you would do if you had just defined a new service or something inside of systemd. What that does is when systemd comes back up, or when the systemd environment, when it reloads that daemon, it will reread Quadlet, and Quadlet will execute and regenerate all of those definitions. And now if I did a systemctl status on httpd-podman, it should come up and say, hey, I know all about that thing, but it's not running yet, right? Because it isn't supposed to be running yet. If I do a systemctl stop, again, sudo, I should just sudo su. Okay, if I start it up, now if I do the status again, it should tell me now it's active and it's running, right? And it gives me the output down here from Podman. If I did a Podman logs, you'd see the same output from the container as you're seeing right here inside of that system service. So I close that. If I do a sudo podman ps, you're going to see right there, systemd httpd podman is running. And if I do that curl again, there it is. It works, right? So that's cool for a container. And there's ways to use Quadlet to run containers. You can run pods. You can start up a volume. You can build networks. Anything you can do with Podman, you should be able to do with a Quadlet as well. So you could define your entire Quadlet infrastructure or Podman infrastructure in Quadlets, and then they'll come up with systemd instead of you having to do anything within Podman. So that's already a huge step forward, right? You think Fedora, RHEL are ready to compete with Mac OS on the desktop? Personally, I run Fedora on my personal workstation, and I don't look back. It dual boots Windows for a handful of applications that I just can't find alternatives for, but 98% of my computing happens on Fedora. So I would say yes. Is it identical to Mac OS? Probably not. That application that I run on Windows, I could run on Mac OS. Can't run it on Linux. Very frustrating. Let me continue on here. So we also did that pod. Remember when we defined that YAML file? We can run those using Quadlet as well. So I have a demonstration of that right here. Let me just open it up here. That was the wrong one anyway. Vim WordPress pod. And this is actually a lot cleaner if you look at it, right? All we really have to tell it, because all of our definition happens in that YAML file. All of our volumes, all of the naming and the environment variables and everything. If you remember, there were environment variables in there that told MariaDB how to start up, and it told WordPress how to find MariaDB, right? So what we can do here is tell it, here's the YAML file for my Kubernetes YAML file, and we tell it what port it has to open, and that's it, right? So let's go ahead and copy this in place. Okay. Oh. Why didn't somebody remind me to type sudo? Come on, people. Okay, and then you'll notice that in the WordPress pod, you see the directory or the path I'm calling for this YAML file is also in etc containers systemd. It doesn't have to be there. You can put it anywhere in the file system as long as systemd can read there, as long as Quadlet can read there, and as long as Podman can read there, then it should work. It's easy to put it inside of etc containers systemd. You can just say it's here. You can specify it as just YAML equals and then the name of the YAML file, and it'll use the relative path of etc containers systemd. So you don't have to worry about typing in a longer path. The number of times I've typoed those, and then why won't my service start? It's because it can't find the YAML file. Okay, I need the YAML, so that's right here. Oh, that's the other thing I need to change. Remember, we have this going to my home directory. Remember, I pointed this to my home directory at the beginning. There was a reason at the start of this it was not pointed to my home directory. That's because if I'm going to run this container through Quadlet, if I'm going to run it as root, it doesn't make any sense to put the data volumes inside of my home directory. Instead, I'm going to put them in /serve/containers/ I think it was WordPress. You don't have to put it in serve. I've been tinkering around with image mode as a container host, and serve is not a good place to try to put things because it's immutable. So you have to put it inside of var. So I moved it into var containers instead of serve containers. So just keep that in mind. Okay. Now let's make sure those still exist. I forget if I cleaned them up or not. Hey, there's WP. I did call it WP instead of WordPress. WP. So that should be there. And I think that means I already have a database and stuff there. And my machine locked again. And I typoed the password. Sorry, I have a second machine here I'm using for the web demos. That's why I keep having to go over there. Okay, so we have the YAML file corrected. We have the paths. We know they exist. Now we just need to copy wp-pod into etc containers systemd because that's where we told the sudo. That's where we told it to find the file at. And there we go. Now it should, if we do a sudo daemon reload. Oh. Sometimes I type too fast. Okay, and there we go. We're back in that same state where it's loaded, but it's not running. Okay, now if I tell it to start, that will execute the YAML definition and make a pod in the same way that it did when we did it with Podman Play, right? So if we do a sudo podman pod ps, then there's WordPress running again. And I could show it to you running over in my browser just to show you. So there, that's the old instance of it. If I were to refresh this, it should come right back with the same setup page. Yeah. So again, it's the same setup page because we didn't go through and actually set up WordPress when we did that. Okay, so the big reveal is, do these things persist a reboot? Because that's exactly what I was trying to fix. Let's watch it reboot. What should happen now is it'll do the reboot, and then systemd will bring those back up and running when the system boots back up. Let me take a look at chat here. See if anything crazy is going on. How to pull images if your servers are airtight. You would have to have a local registry, right? You can pull down an image locally. You will have to have a machine that's connected to whatever the public registry is you're getting images from, unless you're building your own images. But the bottom line is you'd have to get copies of the images you care about and put them inside of a local container registry that's either running on the machine that's air-gapped or on another machine that the air-gapped machine can reach, right? I know air-gapped machine can reach, right? So I'm assuming you're in an isolated network space. and you could run a registry within your local air-gapped network. If you have a single machine that's air-gapped, which would be weird, you could run the registry right there. But then you'd have to do all your container builds right there on the machine and push them into the registry, which would be tricky. Yeah, the images need to pull from somewhere. Well, that's the somewhere. Looks like there were some other answers to that question. Can run Podman save. I'd have to look at Podman save to see if that gets the same thing done or not, but it's possible. Okay, I think that's everything. So let's connect back to this machine. So remember, we have the HTTPD container. There it is. HTTPD latest is running again, right? It's up. It was created about a minute ago. That's when the system booted. These things get removed and replaced when you start the service back up. And then, of course, we've got MariaDB and the other Apache that's running WordPress, right? So if I were now to do a sudo podman pod ps, we should see the WordPress pod. And there you go. So there it is. Service is up and running again. Okay, so that's awesome, right? We can do this with Quadlet. So we're done, right? I've got one other cool thing to show you, and that is automating these deployments using RHEL system roles. There is a Podman system role that can do this work for you. For the sake of this demonstration, I have 2 separate machines here that we're going to try to configure in an automated fashion. So let's go over to, I have this all configured now, so there shouldn't be a lot of chance for typos. First, let's look at the container. Okay, let's open it in Vim. Okay, so if I want to deploy a container, it's really simple. There is a container role within the Podman system role, and you can see this is running the Podman Quadlet system role. So what this will do is it'll make a Quadlet that will run the Podman container, right? What this is actually doing is it uses the system role to figure out what you're trying to deploy, and then it deploys it as a Quadlet, right? It makes sure that all the supporting things that you need are in there. It makes sure that the firewall is configured. That's what this stuff up here is. You can see I've got Podman Firewall. A firewall D is there. It'll configure firewall D so that you'll be sure the ports are open, right? I had typoed this. I'll fix that while I'm at it. See, and I said there wasn't going to be any typos. There's an extra P at the end of Podman. That just bothers me. It's just the name, right? So Podman Quadlet specs. We're going to do HTTPD. Podman is the name of it. It's going to run a container. Here's the definition for the container itself, which is the image, which is HTTPD, the port that it needs to publish, which is 8080 to port 80. Again, you can do these environment variables. These here commented out as optional. You can also map in a volume if you needed to. And then here we can tell the service how the service is supposed to behave and what target it's supposed to start up with, right? So let's go ahead and save that because I did make that minor typo correction. And now all you have to do is run this. I'm going to specify the inventory file, and then we're going to call HTTPD Podman. And this is going to deploy it on the first of the 2 machines, right? So it's going to go ahead and do its thing. Just looking at chat here while it runs. Throat's a little dry. Sorry, folks. Yeah, I think all the questions have been answered. So we're just gonna sit here and watch Ansible run. So yeah, what it's doing here is it's making sure that the Podman packages are installed, which I did not put on to begin with. In fact, that was the whole point of it. Here, let me switch over to the one we haven't touched yet. You see, Podman's not even here. The firewall D is not even installed, right? So it's going to install firewall D as well. We told it, open this firewall port. And if we had not told it to open the firewall port, I don't think it would install firewall D. But it knows that if we're going to open a firewall port, we need a firewall. So it's going to assume that we wanted it to install it. So it goes ahead and does that. There it is doing firewall stuff. Okay, and it is done. This should work. There we go. Now we got the it works from the host that I'm managing, right? So if I were to hop over to that machine, this time I'll just become root. I do a Podman PS, there it is. We've got our HTTPD container up and running. Etsy container system D, you can see right there, there's the container def. And it should look a whole lot like the one that I did manually. So there you go. You can see it's similar. Okay, so it doesn't have every single thing that I put in it. But again, this was done automatically with the system role. So of course it's going to look a little bit differently. It didn't just copy in the thing that I did. There is a way to do that. And that was the way I was doing it. Today, when I started figuring out how to do the pod, which we're going to show you next, I decided to embrace the full features of the system role instead of doing what I was doing, which was I would make the Quadlet file, I would make the YAML file, and then the system role place those files and then start them up, which you can almost do without the system role. So I decided, let's see if there's a better way. That's what I did. I'm going to show you that in just a moment. I don't see any new questions. Hope you guys are enjoying the content. If you do, hit the like button, because we like when you like us. We're always seeking validation. Okay, so the pod. This one's a little more complicated. You notice that inside of files here, I already have the pod definition, the YAML file. It's practically identical to the one I showed you just a minute ago, so I'm not going to go through it again. But some of the paths may be different. But that's in there inside of files. And you could, using like Jinja templates, create that on the fly instead of putting the file in. I find that a little more constraining when I'm working with these, because usually when I have a pod defined, I know exactly what I want it to look like, and it's not always identical from one service to the next. So you might use a Jinja template if you have a whole bunch of services that look pretty much identical that you want to run over and over and over again. But in my case, the services that I run, most of them don't look the same. So I just make the YAML file for the pod definition, and that's how I get this done. I confusingly named the files the same thing because Ansible also uses a YAML file for the playbook. So for this one, what I did was I tried to make things a little more dynamic by specifying the app name and the service name inside of variables, and then I call those later. And this is partially a carryover from the way I'm doing it on that image mode host that I was poking around with. But I thought it worked out well, so I kept it. So I set some variables here. The other thing, remember we had to manually make those directories? That's not great when you're dealing with automation. Now, maybe you could say that the file system already existed on the target machine, but I don't like to leave that to chance when I'm doing like true automation. So what I did here is I made a list of directories this thing depends on, right? We're going to make those before it makes the container, before it makes the pod. We got the firewall again. We're going to tell it to port open port 8081 this time because that's where this service runs. We're going to tell it what state the Kube file should end up in. So state equals started. And we're going to tell it where that YAML file is that we defined our pod in. You're supposed to be able to define where it goes to, but I couldn't get that to actually work. So I just commented it out and it works. That's something I'm going to circle back to and figure out why it wasn't working for me. And then we have some Quadlet options here. This is what port to publish and that it should start the service up. This is where I'm making those directories, right? So you can see here, this pre-tasks. What that tells Ansible is run this before you run the normal tasks or before you run the roles, right? And you can see the very next thing we do is roles. You can define pre-tasks after roles. That's not how Ansible works. It'll look for the pre-tasks and run them first. So if I put tasks here and then tried to put the directories inside of tasks, it actually runs roles before tasks. So what it would do is it would try to make the pod, it wouldn't be able to access the directory structure that I told the pod it needs, and then it would fail. So you have to use pre-tasks for that. So these pre-tasks are basically to set up your environment before you run your roles, right? So then the role here is just Linux system roles, Podman, right? So we're going to save this out, or actually just close it because we didn't make any changes. Now we're going to run it. Have to tell it the inventory. And then we're going to do WordPress pod.yaml. Okay, now assuming I got everything, all my ducks in a row, I'm not lying. I was working on this up until like 45 minutes before the show started. So cross your fingers, everybody. I see some more chat. Let's see what I got here. Some more conversation about registries. Do I have a GitLab or GitHub repo where you can see these files? I unfortunately do not. There are lots of examples online. Maybe I can try to find some of the examples and throw them into the notes for today's show. But that'll have to be after I'm done, because I'm not going to do that right now while you guys are waiting. I see another thing about registries. So we can set up a server with an internet connection as a registry. Yeah, as a registry server, and make our internal servers pull from that. So I don't want to try to go off the rails with a demo, but what you do is you do a Podman pull, right? So you do Podman pull docker.io/httpd for the example that I used in my first container. What that'll do is it'll pull that into your local Podman images. This is sort of my local cache of images that this machine has already downloaded and cached. You can use Podman tag to tag one of these images with the registry of your own local registry. So I would do like Podman tag someregistry.com :WordPress, or someregistry.com/WordPress something latest or local or something like that. And then you would use Podman push to push it to that other registry. So you've downloaded that image from the public registry, then you pushed it back to your local registry. Now you've got a local copy of it. That copy will not change unless you pull a new copy of it and push it back up. The problem is that now you're responsible. That internal copy of that image is up to date with what you expect your services to be running, right? Which maybe that's okay, right? If you're running a local registry, you probably want that level of control. That's how I would get that done. And there's lots of ways to run registries. There is a Docker registry, but if you go to Docker Hub and search for the word registry, you should be able to find it. There are lightweight, like Git/registry combinations that you can run in a container. I use GitLab myself. I run my own GitLab instance. It's not public, otherwise I would share this stuff on there. But basically, you can set up your own CI/CD, make your own images, and put them to your own registry, and that's 100% as local as you want it to be. You can wall that off from the internet if you want to. Just look at this last question, and then we'll get back to the demonstration here. Maybe another video topic could be using the Docker registry container to host local registries. Yeah, that's exactly what I was just talking about. I'm going to mispronounce this because I've never heard it pronounced properly. Forjo, but that's another one that people are using for these local registries and local Git instances. Okay, it finished running. So now I can go over here, and if I do a Podman pod ps, you see WordPress is running. Podman ps should look very similar to what we had running before, right? So you can see that's all there. And if I switch over to that other share, which did not lock, I keep fiddling the mouse over here. Okay, you can see there, unable to connect. This is, if you look at the IP address, this is that first host that I had set up as managed. See right here. We're just going to click try again, and it should give us a WordPress login page. There you go. Now, I told you we've got that other host. Let's see if I can switch these. Hey, look at that. All we really have to do to get the other host configured now is we just we have to make sure we type properly first. If I go back to my inventory file and just uncomment this one, that's my second host that I have managed here, and I rerun the exact same command line again, it's going to go through. I haven't done this one yet, so now I got to hope my SSH key's there. Yeah, there we go. Now what it's going to do is it's going to set up the exact same container on this other host. So you could imagine if you had some kind of a high availability setup, for example, where you want this to be deployed on 4 or 5 hosts, you could do it this way. I like GitLab because it gives you the full features of Git for a code repository, and it gives you a built-in registry as long as you want to configure it. And I run it all in containers. The thing I've been tinkering with is I run a co-located server with a company called Hetzner. And what I was doing is it was just running like an old CentOS stream box. And I decided I'm going to make a new machine and I'm going to run full-on bootsy RHEL image mode on that machine. And I thought, boy, if I'm going to manage the OS using bootsy, wouldn't it be cool if I go the next step and finally wrap my head around Ansible and deploy all of my containers that way too? So that's what I've been tinkering with. So I'm actually building my own customized version, not customized, my own standard for an image mode host. I push that into my registry on GitLab. It does a CI/CD pipeline that builds that and puts it into my container registry. And then my RHEL image mode hosts use that as where they get their images from. So it just pulls that down, and I could do a whole other show about image mode. It's a lot of fun. But anyway, that's how I get the base image. And then the containers I'm getting from whatever registry they come from. In some cases, they come from my registry. In other cases, they're coming directly from places like Docker Hub or wherever they're published. And that's how I run my services that way. All right, so that's finished. If I go switch my thing back here. Oh, click and drag. There we go. So this is the other one, the 10.0.0.114. If I click try again, it should have WordPress. So there you go. So now you can see how the Podman system role can make deploying containers, whether you're doing pods or you're doing individual containers, pretty easy and automatable. That's what I wanted to show you guys today. So I hope you guys have enjoyed today's show. Let me turn off my shares here. All right. I hope you've enjoyed this. Make sure you leave a comment if you have any questions, if there's anything we didn't talk about in the chat, if I missed it or something. Like I said, I'll see if I can find some examples of how these system roles work, how Quadlet works, and I'll throw them into the description of the video. Just give me some time to dig those up and get them put in there. All right. Well, folks, I hope you all have a great day. And yeah, we'll catch you in the next one. Have a great one.